Hello, hello. Hopefully everybody can hear me. Welcome to the Things Conference Spring Global. This is the Q&A stage of the Spring Global, where we are streaming on all platforms. So that's YouTube, LinkedIn, and we're doing that through a platform called Restream. And here we are also going to conduct Q&A. We're going to show what's happening on the main stage of the platform Hopin, where we're holding the conference. So the advantage of Hopin is that if you're in Hopin and attending the Things Spring Global, you can see all the live content free. In the first row, you see it live. You can interact with speakers. You can ask questions. You can meet other people in the LoRaWAN community. And so if you're interested in developing with LoRaWAN, the Things Conference is the place to be. If you're on another platform like YouTube or LinkedIn, there should be a link in the description below where you can join the conference and hop in, and you can sit in the front row and see all of the content. Otherwise, I'm going to pulling up some of the content from the conference itself, and so we can watch that together here. But for the real experience where you can interact with the guests, we really encourage you to try to jump in and hop in. And if that's not possible, all of the content will eventually be available on YouTube afterwards. So I'm going to play a short introducing the conference, and you'll understand what exactly is on today. Let me see if I can pull that up. Here we go. And okay, let's see. Welcome to the Things Conference Spring Global. This is our first time doing a conference focused on a US audience, and we also have a lot of exciting The Things Industries announcements to make. Today, we'll set the agenda for LoRaWAN development in the next year. We'll discuss the market and where it's heading. We'll talk about relevant use cases, and we'll give examples of how to scale effectively. There'll also be an update on The Things Industries itself, where we are and where we're heading. We'll share some numbers about the messages and devices that we're supporting in the back end to give you an idea about the actual impact of LoRaWAN right now. Finally, we'll address pain points we consistently see our clients facing, and we'll have lots of questions and answers along the way. Welcome, enjoy. I just realized I'm on mute, sorry. Yeah, so that was a clip from the main stage. That was just to welcome the conference. Today we have lots and lots of exciting content for you. So Krishna is going to talk about provisioning devices at scale. Hilke is going to talk about automating device management. I have a session about finding the right LoRaWAN device for your use case. Adrian is going to talk about integrating LoRaWAN into your corporate ERP systems. And then, of course, we have lots and lots of behind-the-scenes updates and announcements from the Things Industries. All of these presentations are on the LoRaWAN stage in Hopin. And here I'm just going to share part of those clips, and I'm going to do live Q&A. So after all the guests are live on the main stage in Hopin, then they'll over here where I'll interview them. And so if you're in the Hopin platform, then we'll be answering questions from guests. And so if you have any further questions about anything that's played on the main stage, jump in the Hopin and ask. There should be a link in the description below if you're on YouTube, if you're on LinkedIn, if you're on another platform, where you can actually join the conference. So up next on the main stage, we have Vinke presenting the state of LoRaWAN and discussing some use case verticals with a big upside. So let's watch the beginning of Vinke's presentation here. Let's see, there we go. And I will put myself on mute, and here we go.
Hello, welcome to today's edition of the Things Conference. Today we're going to tell you all about building LoRaWAN solutions at scale. My name is Wienke Gieseman, CEO and co-founder of the Things Industries. Here at the Things Industries, we help customers around the globe building LoRaWAN solutions, from cattle tracking in New Zealand to helping mining companies with their conveyor belts monitoring in Chile. LoRaWAN is cracking a lot of different nuts, and we see that we have a massively diverse customer ecosystem. We help German supermarkets with pest control and smart mouse traps. We help facility management companies in Japan with monitoring their HVAC systems, and we help thousands and thousands of quick service restaurants around the world with their temperature monitoring of their fridges. Together this year, with our customers, we will be connecting 1 million LoRaWAN devices across the world. Over the last 7 years, we have gained a massive amount of knowledge around building LoRaWAN networks and supporting them. We have embedded that in our LoRaWAN network server called the ThinkStack. We host it through our cloud platform all across the world for our customers to make sure their IoT data keeps flowing and they keep the IoT operations and developer operation costs low. Our team is constantly improving the product, and we're releasing a new version seamlessly every 3 weeks. So we provide all the tools and all the systems you need to operate a LoRaWAN.
So that is Vinke on the main stage at the conference. In case you're just joining, you're watching the Things Conference Spring Global. We're live here on YouTube, on LinkedIn, and conference itself is happening in Hopin. So if you want to join in and see all content live, ask questions, hopefully there's a link in the description on the platform that you're watching, so you can see down here in the corner what's happening on the main stage. And if you're interested in asking questions and actually interacting with the LoRaWAN community, then we really encourage you to join in Hopin. On the main stage right now, Vinke is talking about some of our most interesting clients at the Things Industries. He's talking about cattle tracking in New Zealand, about mining in Chile, about grocery stores in Germany, using LoRaWAN to improve their business processes. And I know he's sharing about the enterprise features in the ThinkStack, how we use open standards to prevent lock-in, and then he's discussing some of the verticals with the most upside in LoRaWAN. At the end of the conference today, Vinke will be doing a Q&A. So if you're on another platform like YouTube or LinkedIn and you want to have your questions answered, then please join us in Hopin. Yeah, if you're interested in developing with LoRaWAN, of course, the Things Conference is the place to be. So if you're watching on another platform, there is still time to join, and I hope to see you in Hopin. I'm going to cut back to Vinke right now so you can continue to see what's going on the main stage.
Exactly the same to your IoT application or your ERP system, especially now when hardware acquiring gets very hard through the component crisis. You'll see that it's very beneficial not to be locked into a single sensor vendor. Many of our smart building customers, they are using the ThinkStack Cloud, mainly because it's the most cost-effective way of running a LoRaWAN network server, because you do not have to employ any IoT ops or developer operations to run the network server yourself. We have many customers that operate a large amount of buildings, resulting in a large amount of sensors that need to be provisioned or to be installed. Our tools allow you to do that very efficiently through mass import, also through scripting and the CLI and our APIs. For connecting gateways to the ThinkStack, we support open standards, making sure that generic software talks through an open standard with a network server, making sure there's no lock-in between the gateway and the network server. After the ThinkStack, the data is fed into many different systems. So if you look at smart building, it's very easy to integrate the ThinkStack and the sensor data through webhooks or through the APIs into your existing building management system. So that wraps up a bit on all the features that we have to offer when you're trying to build a solution into the smart building vertical. So next up is smart metering. So the typical anatomy of a smart metering LoRaWAN solution is that you have several well-placed gates.
All right. So that is Vinke on main stage again, talking about some of our most interesting clients in the Things Industries, talking about enterprise features in the ThinkStack, and discussing 4 verticals with massive upside for LoRaWAN. So those verticals are smart buildings, smart metering, industrial LoRaWAN, and tracking. And at the end of the conference today, in a couple of hours, Vinke and Johan will be available for a live Q&A. So if you're watching on another platform, you're watching now on YouTube, on LinkedIn, there should be a description below where you can join and hop in, and then you can actually interact with the speakers. next up on main stage, we have a technical update from Johan, where he's going to dive even deeper into a lot of the things that Vinke is talking about in the opening keynote. And so I'm going to pull that up, and we can watch some of Johan's technical update. And let's see. Okay. So here comes Johan on the main stage to talk about new features in the Things Stack.
Hi, my name is Johan, and today I will be presenting a quick technical update about what we have been doing. We have not been sitting still last year, and also a few exciting things that we are releasing later this year that I'm really happy to be able to show you today. So first, a few updates about the Things Stack. So in last year we added a couple of new features, including LoRaWAN 104 support and the latest version of the regional parameters. And this means that we also support LoRa FHSS, which is the modulation that will primarily be used by satellite communication. So that's also really exciting. We also improved our adaptive data rate algorithms, and we added a lot of settings that you can use to fine-tune the data rates and the transmission powers that your end devices are using. We also added a couple of new integrations, including Azure IoT Hub and IoT Central integration, and we also added health statistics of your webhook integrations. So if you have a webhook integration and the server is a bit slow or it's down, we'll give you notifications. We added bulk import, so if you want to migrate your device fleet from another network server to the Things Stack, or between the Things Stack deployments, or if you want to import CSV files with end device data, you can now do that. And finally, in Packet Broker, we added advanced routing policy configuration and gateway visibility configuration and support for LoRaWAN backend interfaces, but more on that later. So the Things Stack, as most of you probably know, supports 4 different deployment models. We have the Things Stack Cloud, which is our fully managed environment with all our feature set enabled. And the Things Network is also a managed environment, but that is for the community network, where everyone works together in one collaborative way, which is intended really for public use cases. You can also run the Things Stack yourself. We have the enterprise distribution, which is our fully featured commercial setup that you can deploy on your private cloud or on bare metal if you want. And finally, we have an open source distribution that you can find on GitHub, and that makes it really easy to get started. All these, the Things Stack deployments, they share the same API and the same configuration, and that means that you can pretty easily start on the Things Stack open source, and when your deployment grows, you can migrate to the Things Stack Cloud. On the Things Stack Cloud, we have our service, public service status page that you can find on status.thethings.industries. And yeah, we are pretty proud and happy with our operational performance the last year. We have been seeing 100% uptime since June last year, so we are really excited about that. The Things Stack is open source, has an open source core, and you can find on GitHub the Things Stack source code, but you can also see the internal issues that we track and also the milestones. And so we produce roughly 20 releases per year. That means that every 2 or 3 weeks we have a new release, and we update the Things Stack Cloud and the Things Stack Community Edition also every 2 or 3 weeks with the latest version. If you want to see what's coming in the next versions, go over to GitHub, to our repository. You can find that on github.com/thethingsnetwork/LoRaWAN stack. And you can see exactly the issues and the milestones and everything that's coming up. And if you want to request a feature, or if you have a bug report, please also do that on GitHub. So it's open source as a core, but also we are really transparent with our development process. We have two exciting new features on the roadmap. First is the notifications service, and that is a service that will send you text messages or email notifications of things that you should know about. And we are going to add this gradually in the versions that we are releasing this year. First, we start with some basic administrative and security notifications. So if you are a tenant administrator and a user signs up that needs approval, you will get a notification for that. So those are really simple things that we start with. Later on, we add notifications for events of things that happen in your network that you should know about. For instance, when a gateway goes offline, or when a device joins for the first time, so that you know everything works. And you will be able to configure events for that as well. And finally, we'll be adding notifications for more advanced network behavior. And that includes any anomalies with gateways or devices, but also suggestions for potential other networks to configure peering with through Packet Broker. So that's one of the two big features that we'll be adding later today. The other one is the Network Operations Center, and that will provide historical insight in the performance of your network using mostly nice visualizations in the browser, and it's fully integrated with the Things stack, and it's powered by Grafana. And I think most of you know Grafana. It's an open source, really well and fully featured dashboarding tool. And so we built an integration with that. Examples of this that you will be able to see are the gateway packet rates, channel utilization, the channel noise, how many devices are seen by your gateway, devices that are seen that are registered to other networks, things like that. But also on a device level, you'll be able to see the historical data rates, to see how the ADR profile is working, as well as the packet loss rates based on frame counters that are not incrementing, but also which gateways are covering your devices and what the RF qualities are. Finally, on a group scale, so devices that belong to applications, we will be analyzing the device health in the application. So that's really exciting. So this is a lot, and we will do our best to make it really easy and digestible for you as a user. So it's going to be available only in the ThinkStack Cloud and Enterprise, and it's going to be accessible for tenant administrators. So we built a first version, and this is what it currently looks like. So here you see a gateway performance, and you can see the timeline here. You can select historical time, and you can zoom in to find particular time windows that are interesting for you. You can really zoom into the 5-minute level and see exactly what the traffic flows are, channel utilization. You can quickly switch to another gateway, select the time window, see the channel noise and all those things. So this is only for a gateway, and again we are adding more views to this gateway view, as well as these sort of visualizations, but then for end devices. So then Packet Broker. So Packet Broker is our LoRaWAN backbone for interconnecting LoRaWAN network servers. So if we look at all the features that make...
So that is Jan now on the main stage, talking about new features in the Things stack, like LR, FHSS support, advanced ADR, some new integrations, tools for both devices management, and then the really exciting things on the roadmap, which we have, which are the notification service and the network operations center. And he was showing a video there of what it looks like to use the network operations center, where you can monitor the gateway health and lots of other things about your LoRaWAN deployment. And that's based on Grafana, which gives you this really nice, beautiful overview, and it's built also on open source software that is tried and tested. Now he is talking about Packet Broker, and I know that he's going to make an announcement about new connectivity to platforms like Actility, ChirpStack, and LoRaWAN. and then he's going to talk a little bit about the number of messages that Packbroker is currently routing per year, and about the device repo, and about the join server. And I'm just taking a moment here to interrupt, just so that everybody knows what you're watching. You are currently watching the Things Stack you're currently watching the Things Conference Spring Global, and so we're live a few platforms. We're live on YouTube, LinkedIn, and so if you're watching somewhere else, I am conducting question and answer on this stage. This is the secondary stage of the conference, and I'm talking a little bit about what's going on in the main stage. And just giving a play-by-play, and then we will also do, like I said, we'll do Q&A. So all of the speakers on the main stage come over to this stage, and we will ask questions. And so you're in Hoppin. We'll also be taking your questions, and all of our speakers will be answering them live. Hopefully, on whatever platform you're watching on, there is a link in the description so that if you would, you can still join. And yeah. I also want to take a moment to plug the Things Conference. So we're getting really close to the 5th edition of Things Conference now. Please save in your calendars. That's on the 22nd to 23rd of September in Amsterdam, and then it's also virtual. And we have lots of really, really cool partners and a lot of really cool surprises prepared. So the main topic of this conference is digital transformation. And we'll have speakers talking about exciting new things like cloud integrations, LoRaWAN multicast to update price tags in e-paper, are just some of the presentations that we already have confirmed. And yeah, so that is the place to be if you are interested in LoRaWAN development. That's the Things Conference, September 22nd to 23rd. And you can get your tickets at thethingsconference.com. You also, I need to remind everybody that about a certification program. So if you're interested in LoRaWAN, if you want to learn more LoRaWAN and then show off your knowledge, we have a certification program which allows you to take a test and then demonstrate your LoRaWAN knowledge, and then you can post your badge on LinkedIn or in other places in order to demonstrate that you are a LoRaWAN expert. And we'll also be inviting all of the top performers in that LoRaWAN quiz, or all of the top performers in our LoRaWAN certification program to the Things Conference. So make sure you check that out. That should be on the thingsnetwork.org/learn. And without further ado, I'm going to give it back to Jan. Let's see what's going on the main stage. There we go. And
policy that I have here as an example, and not allow other networks to send application layer downlink via your gateways. You know, those are typical routing policies that you can configure. So we give you a lot of control using that. If you are not using the Things Stack, if you're using Utility, ThinkPark Exchange, Laureate, or Chirp Stack, you can also configure this, but you have to use the command line. But we still support this fine-grained routing policy control. Another part of this technical update is about the device repository. The device repository, for those of you who don't know it, is the largest collection of LoRaWAN devices. It's a structured collection, so it's a database, so to say. It's an open source database that includes LoRaWAN device profiles, payload codecs, so those are the small scripts that are decoding binary payload into meaningful data and the other way around. But it also includes more information about the end devices, like hardware versions, firmware versions, the sensor types it supports, any other regional compliances and things like that. We have almost 3,000 LoRaWAN device profiles in there, and they are contributed by the community. So typically device makers do that themselves. But if device makers struggle with adding their devices, the Things Industries is also there to help and to assist. So there are 90 vendors in there right now. We have over 300 verified codecs with a lot of test cases, and over 100 people already contributed to the device repository. So we're really happy with that. Another thing that we're adding to the device repository, we're currently in the design phase, is to be able to output normalized payload codec. And that means that Currently, decoding the payload from binary to structured data is not typed. So there can be different data structures that are being used by different end devices. But very often you may want to have a normalized structure. So if you have a temperature sensor, for instance, you just want to receive temperature in a unit that you support with the data fields and the field names that you can interpret. So we are currently working on normalizing the output from the decoded payload into a format that can be supported by all end devices. So more on that also later this year. We use the device repository extensively in the console. So here you see a video of adding a device in the console. So you can select the brand, the model, and then it loads the available versions and also the regions that are supported by the device. And the only thing that you then have to add is device-specific information. We're going to make this even easier with the Things join server. So as you see here, you still need to enter your join UI, def UI, and maybe also your LoRaWAN root keys. But ideally, the root keys are not sent to you, but they are on a join server. And this is what we're also launching this year. So the Things join server, what is a join server? So a join server is a critical component in a LoRaWAN network that is used for activating devices. So when a device sends a join request to join a network, the network server contacts the join server to activate a device. And what the join server does is that it authenticates the network server. So it decides which network is going to activate the device. And it also derives the network session keys and the application session key that are then securely sent to the network server and the application server. Today, a lot of people are not using join servers like third-party join servers. So they basically enter the root keys in the network server and then the network server activates the devices. So why would you need to use an external join server? And that is really for security, primarily, because ideally you don't want to expose, as a device maker, you don't want to expose your root keys ever, because that makes it really hard to move devices between networks. It's also to be compliant with upcoming regulations. So we expect that the EU and NIST are going to make sure that it will be impossible to actually expose root keys in order to comply with certain regulations. And that is also where a join server comes into place. And if you use a join server as a device maker, you don't have to send your root keys anymore to anyone. And that also makes that you don't have to think about how you distribute root keys. And today that still happens on paper or Excel spreadsheets that are sent as email attachments, and that's not really secure. It also allows end customers to switch networks or to switch deployments. So if your keys are at a join server and your customers want to switch from the Things stack open source to cloud, they can just reclaim the device in cloud without transferring any key material. And as a device maker, finally, since a join server is always used as part of the device activation procedure, it provides you insight in which device is activated by which network and when. So you get an idea of the activity of your end devices once they are out there in the field. So that's what we're announcing. We're building this as a product, and it's really intended to be used by device makers. So we are already engaging with a bunch of device makers that are also already testing with this, and it's really built for them. So we implement all the LoRaWAN functionality. So it supports all the LoRaWAN versions, all the backend interfaces, specifications. It supports device claiming. It's compatible with the LoRa Alliance QR code. And you can use it as a bootstrap join server. So that's basically the first join server that your device uses. And then a handover to the final join server. So that's a new feature that is coming in LoRaWAN 1.2. But you can also just offer your joint server as the only joint server, and you can still send the root keys to your customers if you want, but you can at least give them the choice to use your hosted joint server. And finally, we do all the interrupt testing, all the verifications with all the LoRaWAN network servers, so you don't have to think about that. And then I hear you thinking, oh, I'm a device maker, so I don't know how to operate a joint server. So for that, we have different deployment options to make it really easy for you. So we distribute the Things joint server fully serverless for Microsoft Azure and Amazon Web Services. And that means that we don't need any compute. You don't need to spin up any virtual machines in your cloud. In case of these public cloud deployments, these are just Azure functions or AWS Lambda functions that are fully managed and scaled by these cloud providers. So there's no compute, there's nothing to worry about, everything scales automatically, and that works really well. And if you want full control, if you are comfortable with operating cloud services, you can also use the Docker or Kubernetes distribution. And finally, if you don't want to bother with any deployments yourself, we can also do that for you. And it will be a white label joint server that's owned by you but operated by us. If you want to get started with this as a device maker, as a systems integrator, or as a distributor, please reach out to us, sales@thetingsindustries.com, and we can help you getting onboarded today. So that's the technical update. Thanks a lot for watching. I will be joining the live Q&A later today, and for now, enjoy the conference. Thank you.
So that was Johan giving a technical update. Let me double check that I'm okay. Yeah, that was Johan giving a technical update from the conference. He was covering new features in the Things stack, tools for bulk device management, packet broker update, some exciting roadmap update items like the notification service and the network operations center. And he showed a little bit of a video of some upcoming features, which was really exciting. And then also really amazing news is that we, through Packet Broker, now are able to share LoRaWAN messages with networks like Activity, ChipStack, Laureate, and Packet Broker is currently routing 30 billion messages per year. So LoRaWAN is having quite a big impact, and there's lots of messages going around, flying in the back end. The device repo, also some exciting updates. Now 2,952 devices integrated in the device repo, which also integrate then easily with the Things stack. And he talked a little bit about the joint server there at the end. So next up we have Krishna. I'm going to play a little bit of Krishna's video before we do the Q&A with Krishna, just so everybody gets an idea of what's going on in the main stage with him. Let me see. Uh-oh. So here comes Krishna to talk about provisioning LoRaWAN devices at scale.
Hi, I'm Krishna from the Things Industries, and let's talk about your devices at scale. So once you get past the initial testing stage, you might have hundreds or thousands of devices that you want to work with, and you will quickly run into the problems of scale. So in this video, I will give you some information on how you can solve these problems at scale. My personal framework of looking at this is through the 3 layers of scale.
The layers of scale is a convenient framework to understand how device security works in a large fleet. The 3 layers of scale are as follows. The first layer is to manage the delivery of your device fleet. When you're a device maker, transferring a large number of your devices from your factory to your customers can be a tedious and highly error-prone task. The user then has to individually clear these devices on the network server of choice. So the Things stack provides a bunch of options to do this seamlessly. You can use CSV file provisioning or our device claiming features, as mentioned in our documentation, to be able to do this seamlessly and quickly. So the next level of device management is device fleet security. So it's not a good idea to send your users a file containing all the keys for all the devices. This happens quite a lot in the past, and we would want to avoid that. This is where the Things Join server comes in. Instead of sending keys to your end user, you securely provision it on the Things Join server, and then you send the devices and certain device information to the end user. So the end user then registers the device in a LoRaWAN network server, and the LoRaWAN network server talks to the Things Join server to get the device session keys. And finally, we're going to close the security loop.
So that's Krishna explaining how to provision LoRaWAN devices at scale. And I actually have Krishna here in the backstage, and I see him there. Hopefully he can hear me and he's ready to come on. And so the fun thing about the way we're doing this conference is that all of the speakers who are presenting will then have a chance to come on here and do some Q&A. So I'm going to bring Krishna on right now, and then we'll ask him some questions. Howdy, Krishna. Can you hear me?
Hi, Ben. Yes, I can hear you. I hope you can hear me too.
I can hear you perfectly.
Yeah.
So what would you say is the most exciting thing about what shared at the conference today?
Yeah, so the most exciting thing about what I shared is that this actually allows device makers to have a very easy way of securing their own devices, but also protecting it in their domain. So that the difference what we have with the new join server and the way we provision devices is that, first of all, it's secure. So it covers the baseline security of LoRaWAN that is stipulated by LoRaWAN regulations. And on top of that, it makes users very easy to deploy their own join server in their own AWS or Azure accounts, because we have a very easy serverless implementation of it. So that combination makes it very, very easy to spin up your own join server and manage it at a large scale, which also means that you have your own protected domain.
Okay, and for people who are using the join server previously, what are some of the new features of the new join server?
Yes, so the new join server is actually completely LoRaWAN compliant. So we support LoRaWAN 1.1, 1.0 as we did before. The big advantage with the new LoRaWAN join server is that it's a lean implementation. So the thing with the old join server, or the join server that's currently running, is that it's a component of the Things stack, and the Things stack it's not just a join server. Things stack is all of our products, and you can run the Things stack as a join server only variant. And we found that that's a bit difficult for people who don't have operational experience to run. So what we did was we extracted the logic of the join handling, joining, provisioning, etc. And then we made a separate, very lightweight implementation of the same LoRaWAN join features with additional support for easy provisioning, CSV file support for easily drag and drop the secure elements, secure element manifest, etc. So it's a very lean implementation of the existing LoRaWAN joins logic, let's say. So that the biggest advantage is that the join server that we have now already provides you the necessary LoRaWAN security, but with the new join server, it also makes it a one-click deployment, which you don't have to operate if you don't need to.
Okay, so in my role, what I'm most concerned about is how we make LoRaWAN as easy as possible for people to use. So can you talk a little bit about how the new join server makes it easier for device manufacturers and then customers to onboard LoRaWAN devices?
Exactly. So the thing is, the LoRaWAN join server itself is something an important component of a LoRaWAN architecture, because it's the place where your LoRaWAN, the backbone of LoRaWAN, let's say the LoRaWAN security exists. The keys are supposed to be present at the join server, and the more easy we make people to use a join server, the more that they will adopt using a join server by themselves. And then it makes LoRaWAN security work better. So if you make setting up your own join server a multi-step process requiring lots of configuration and operational experience, it makes it very difficult for people who don't have either the time or the inclination to run their own microservices to be able to have their own join server. But if you make it as simple as a simple cloud product that you can sign up on any of the major cloud platforms, AWS, Azure, click a few buttons, set up some configuration, and it's already done, then anybody can easily spin up their own LoRaWAN join server, which means that you not only make it secure, but you make security very easy.
Cool. I like the way that sounds. Not only make it secure, it makes security easy.
Yeah.
And for customers?
And for customers also. So if you if you are provisioning devices or you're deploying devices in hundreds or thousands, then it's really a pain for you to onboard individual devices and make sure their security is taken care of. And for example, in the future, if you want to migrate from one deployment to another, then you have to also move the keys and also do a rotation of the root keys on your device, which is quite difficult even with FODA enabled. It's very difficult to also do that. So once you have a join server that is in your own domain, which contains all the keys, then you only delegate the job of handling the traffic to the network server. And then you can easily switch between network servers, or you can easily delegate the job to another network server if you want to. So having the keys securely in your own domain and very easy to maintain, very easy to update means that your security becomes quite easy for large-scale deployments when you have tens or hundreds of thousands of devices.
Cool. Okay. I think there's some technical things about where the stage is streaming in the backend that I want to fix. So I'm going to let you go for now, and I'm going to put the next video on, and then we'll continue on with the Q&A on the stage, and maybe I'll see you again later.
Perfect. Okay? Thanks, man. Ciao.
Appreciate it. Ciao. So that was Krishna to answer some questions after giving his presentation of provisioning LoRaWAN devices at scale. And the next video coming up is actually by me, and it's me sharing my process for choosing a LoRaWAN device. So I will pull that now. And here we go. So, you've learned a little bit about LoRaWAN and you want to get started building your own LoRaWAN solution. Well, one of the first steps is choosing the right device for your LoRaWAN solution. So today, I'm going to walk you through my process for choosing a LoRaWAN device for my application using the LoRaWAN device repository. Let's get started. So today I'm building a LoRaWAN application and I want to add a window sensor in my home so I know that when a window is open or closed. And I'm going to walk you through my process for looking at all the available sensors and then picking the one that I like. So the place I always start is the Things Network device repository. So we go to thingsnetwork.org and then the hardware section. And here we can see all of the devices in the device repository. The sensor that I need is called a magnetometer. And I happen to know that the smart room sensor has one. Soon we'll add some filters to the device repository so it's a little bit easier to sort by sensor. But for now, the way that you do that is you go to a sensor that you know has the sensor you like. And then here, these links all allow you to sort the device repository by this sensor. So if I click this magnetometer link, then suddenly I have this tag magnetometer and I can see all of the devices which have this sensor. The other way to do that is using the URL. So if I wanted, for example, a light sensor, I could do this and then I would just see all the devices which have light sensors. And like I said, soon we'll add a filter so you can just sort that more easily. But for now, this is the little hack I use to sort. If you want to see all of the sensors that are available, I suggest waiting until we add the filters. But if you're a little bit codey, you can go and see those in the device repository itself. So in the repository, the wind sensor example has all of the available devices. And these are all tags that you can use to sort the device repository to see which devices have these sensors. Let me get back to my magnetometer. And now I can see all of the devices, like I said, which have this magnetometer. So the next thing I'm going to do is create a little spreadsheet, which has all of the devices that I want to compare. Here, I've made myself a spreadsheet with the manufacturer, device, which sensors it has, the battery life, whether battery is replaceable, the size of the device, price, and then any notes. And now in the device repository, I can go through and I can look at the devices and I can get a lot of that information from here. So here I have the sensors, and this is the Tectelic smart room sensor. And the size is here as well. And then I can also see example uplinks, which is kind of cool. So you can see exactly what the data is going to look like when it comes in on this sensor. The last thing I need to do is pull up the spec sheet for this device so I can see the information that I don't have here. So here's the data sheet, and I can see the battery life. I can see some more information. And here's the spec sheet. I can see the size. And in the base version and the PIR version, we have a battery chart here. So let's assume SF7 connection, and we're sending a packet every 15 minutes, which means that we have a battery life for the PIR version of 4 years and a battery life for the base version of 11 years. So this is the base version, 11 years, and the battery is not replaceable. And then for the price, we can go and look for it on the store somewhere. The PIR version costs about 60 euros and the base version costs about 50 euros. This is the base, and we will put those 49.90. All right, and now I'm gonna go and repeat that for each of the sensors in the device repository that I saw. So that's all of these. This is a parking lot sensor, which is not what I want. It happens to have a magnetometer in it, but it looks like I've got a LoRaWAN sensor here. I have the Sezo EL. I have some chips, and then I have the Dragino LDS01 and LDS02. So I go and I repeat that for all of my sensors, and now I have them all here, these two Tictelics, the LoRaWAN, the Sezo, and then the Dragino. It turns out that the LDS01 is discontinued and was replaced by the LDS02, so I just made a note here that it's end of life. But basically we have all of the information for all of devices. We can see what they all cost, and we have the battery life, whether the battery is replaceable, the size. And now the decision is pretty easy. It's kind of a matter of personal preference. So you can make a decision based on the price, maybe based on the size, maybe based on the battery life, if you know how often you're going to replace it. Battery estimates, I tried to do based on a SF7 every 15-minute uplink, but that wasn't available for all the devices. Dragino actually gave me a number of uplinks that they could send, which actually is a more accurate and makes less assumptions. But I'm assuming that I have about a year.
That
says that
is the end of my presentation almost. And that is me sharing some tips for finding the right LoRaWAN device for your solution. I think we got our technical difficulties sorted out here. And so I'm scheduled for a Q&A coming up now, but I think I'll bring Krishna back on because I think there's some people who had questions for him in Hopin, and so if he's hanging around, okay, there he is. Yep. Cool. Okay. There you are, Krishna. Okay. So
Hey.
I interrupted you earlier because we had some technical difficulties. So for the people who are watching in Hopin now, if you can explain again exactly how this new joint server is going to affect them as customers, and how this joint server is going to affect them as potentially device makers. You can sum that up really quickly.
So end-to-end security is built in as part of the LoRaWAN specifications. So if you use the component called the joint server in any part of your LoRaWAN architecture, you ensure that the LoRaWAN root keys never leave this joint server. Now, the problem with the current implementation or the current sets of implementation of the joint servers is that it's quite difficult to quickly set it up and maintain it by yourself. So the new joint server that we are going to launch later this year is going to make it very easy to spin up your own joint server with a few clicks of a button and a few simple configuration, so that you have a fully scalable production level joint server that you can set up in a few set of a button. And so the goal is to make LoRaWAN secure and make security easy.
Cool. Yeah, again, I said I like that expression, to make LoRaWAN secure and make security easy. And does this have anything to do with device claiming support that will be rolling out soon?
Yes, indeed. So the devices on the ThinkStack or any of our the ThinkStack deployments, let's say cloud, enterprise, open source, whatever it may be, it will interact with the Things joint server through the process of device claiming. So assume this case where you're a device maker and you make a few 100,000 devices. You can easily provision those on a joint server, so the keys never lose your own trusted domain. And then your customers, whoever buys your device, if they want to add that device to the ThinkStack, for example, they can just use a QR code, which is part of the LoRaWAN TR005 specification. So you can just print out a QR code or find a mechanism to send people a QR code, and people can just scan that QR code and we will have a mechanism in our console to simply scan a QR code, and the device gets provisioned on one of the ThinkStack deployments, and it will seamlessly work with the join server and get the session keys when it's necessary. So both for the end user who can easily provision devices with the scan of a QR code versus the device manufacturers who can easily provision tens of thousands of devices, it closes the entire security loop and also makes both cases easy for people to use.
Cool. That's like a win-win-win. Yeah, I've tested the device naming, and I mean, using the device repository was really a great step in terms of onboarding LoRaWAN devices. But now the fact that that manufacturers can just send a QR code, and then that's kind of interoperable, more secure way of claiming devices, I think is a really, really cool and forward progressing step. Let me see what we've got in the chat here. So somebody asked, how can you send your device data to the cloud via ThinkStack? I have my TT Indoor Gateway registered and always see live data whenever it's online. However, I have challenge sending my device data to the platform. It doesn't sound like that question is maybe directly related, but maybe we could do some general troubleshooting for this person.
Yeah, sure, why not? Yeah, that's not a problem at all. So if you know the LoRaWAN architecture, you have a device, you have a gateway, which is sort of the bouncer, let's say, of the network, and then you have the cloud service or the ThinkStack running locally on your computer, whichever. So you have a network that's running somewhere, and the easiest would be to use the ThinkStack cloud. You just easy sign up, everything is in the cloud. You don't have to worry too much about configuring stuff, but whichever flavor works for you, that flavor is out there. So you have the cloud, which processes your data, which is somewhere, or the backend is somewhere, and then you have a device, and your gateway is the bouncer. So if you have a Things Indoor Gateway is like your bouncer. So make the most obvious issues would be that your gateway should be pointing to the right cloud instance, for example. So it quite happens that you have multiple clusters. So people might get confused between the clusters because we have the ThinkStack Cloud and the ThinkStack the ThinkStack Community Edition are globally replicated, which means that we have multiple data centers closest to the regions where people use them the most. So we have 4 regions for the cloud and 3 regions for the community network. So it's possible that you have registered your device in one region and you have your gateway is connected to a different region. So then your data might not go to the correct application. So those are like little things you can check. And I think the best place is the troubleshooting in our documentation. And so for these things, you will have clear answers there.
Okay. It looks like I'm getting a lot of messages in the chat saying my audio is not good. I've just tried switching microphones. Can you hear me any better?
I think it's slightly better, a bit more grainy, but it's better, I think.
Okay. Well, we're in the middle of this event, so I don't know how much.
Yeah. You can't buy Amazon won't get to you right now. Yeah.
Yeah, but as long as you can understand me, I apologize to everybody for my grainy voice.
I can also repeat your questions. That's fine.
Cool. So Jack asks, with the join server, can we add the device without having to select the model, etc., from the device repository? Just select the application, scan QR code, and ready.
Excellent question. Yeah, that's an excellent question. So for those who didn't hear, the question was, without having to select the model or the stuff, can you just add stuff directly when using the join server? So the thing is, that is when you register a device, you have 2 types of data. So you have the device identifiers and the device keys. So we call them device identifier plus keys. So it's like this one grouping of data, and then you have device qualifiers. So you have the second grouping of data. So for example, the EUI, the device EUI, the join EUI, the keys, those are the primary identifiers of a device, and those are required to register a device. So only with that much information, you can already register a LoRaWAN device. But the problem is, for the device to actually work, you need to tell which model it is. Model information is not that important. What's actually important is which frequency plan are you using, which LoRaWAN 5 version, which LoRaWAN Mac version are you using. So without that information, the device can be registered technically, but you will not get any data out of it. So these are actually problems of 2 separate domains. The device repository tries to solve the second problem, which is to easily fetch the device qualifiers or attributes, extra information that is necessary for the device to actually function, whereas the join server solves the primary identifier problem, which is your device EUIs and your keys need to be matched, and the keys should be present somewhere safely. So those are actually 2 different domains. But the question is that there is one sort of commonality between them with the LoRaWAN
TR0005 QR code specification, you can also define a LoRaWAN vendor ID and a LoRaWAN profile ID. So a profile ID is a unique ID to a LoRaWAN device profile. And the LoRaWAN device profile contains the PHY version, MAC version, all this information. And then the vendor ID tells you which vendor it is. So we have done it in such a way that with this QR code, or a QR code of this format, the information that you read from it directly maps to something that's already part of the device repository. So if your devices are in the device repository and they have a profile, as defined, so they have a profile ID, and this is defined in the LoRaWAN specification. And we also have somebody working on it to make sure the profiles exist in all the different devices of the device repository. And on the other side, if you have a QR code which also contains the ID of the profile, then once you scan the QR code, the thing stack will automatically contact the device repository and fetch all that information. The only thing is that the model information is required for you to know the regional parameters version. That is not currently supported in LoRaWAN specification. But what I've heard is that they will also add a model ID to the same QR code specification. And once that happens, then all you need is a QR code. Once you scan it, the thing stack will know which joint server to contact to claim it and which device to get from the device repository. You just click some identifiers and your device gets created in one click. So that is where we are heading to. We have one small technical thing that needs to be done. So at the moment, you pre-fill almost all the information. The only thing that you'll have to choose is the model ID. But the advantage here is that from the QR code, we will already know which brand it is. We already know who's the maker of the sensor. So we will already give you a shortened list of possible models, and the choosing becomes smaller.
So when I tested the device claiming using a QR code, it seemed to me like I was actually having a device that existed in another person's tenant transferred to my tenant.
Correct.
And so it showed up. It showed up with Payload formatter and all of the information about the device. But it sounds like you're saying that so the QR code maybe doesn't contain that information, but in the case that the device has already been provisioned in the thing stack, and you get all that information, or
exactly. So we are changing the device claiming concept now. The device claiming used to be a concept where somebody creates a device and they want to transfer that device to you. And the original thought was let each device manufacturer create a tenant on the thing stack, create all your devices there, and then let somebody claim it from that tenant. So we found that this is not really scalable, and sometimes there are use cases where the device manufacturers want to create devices in their own domain and not provision their keys on the thing stack cloud, for example, or on a thing stack deployment. So then we separated those two functionalities out. So instead of creating a device in the thing stack somewhere, you just have to provision it on the things join server, and you just need to let the thing stack know which join server. That's some backend configuration. And when you go to your when a customer goes to get a device, you claim it, and then that will talk to the join server of the device manufacturer. So we kind of restructured this functionality a bit to make sure that it's more scalable.
Okay, and what is then the transition going to be like for people from the old join server to the new join server?
Yeah, we're going to have some migration scripts to make that very easy. So we are already testing that migration with our own old to new join server flow. And once we have that flow ready, it will be a very simple migration script for you to move that.
Okay, and so the process of device claiming that I have used in the past, will that sort of seamlessly change into this new form of device claiming?
Yes,
or
exactly. Yeah,
okay.
That's the whole idea.
Okay, cool.
So we are going to also rewrite the device onboarding page, so we make this much easier for you to find, and it's really easy for you to follow footsteps. So we have very nice redesign of the onboarding page. So if you have a QR code, then the whole onboarding becomes very seamless. 2 button clicks and you're ready. Your devices are created.
Okay, cool. It looks like the last question we have here is about MAC addresses. So somebody says that the MAC address probably has the manufacturer model and serial built in, but I guess that's not really related to the LoRaWAN spec QR, right?
Exactly. So a MAC address is for a device which works on the TCP/IP protocol,
And so gateways will have MAC addresses. The LoRaWAN devices won't have a MAC address because it doesn't do any MAC-related stuff. Now, you may have a device which has both Bluetooth and
Right.
LoRa enabled, or Wi-Fi and LoRa enabled.
Right.
They might have MAC addresses, but that identifier is not unique in the LoRaWAN. It's a different set of identifiers for different namespace.
Sure. Yeah, that makes sense. All right. Do you have any last remarks, Krishna, before I let you go and we get on to Adrian's presentation?
Yeah, sure. So please watch our space, and we will have, when we are ready to officially roll out the Things Joint server, you will have sufficient documentation. And also, we also plan to add not only CLI, but a simple drag and drop console support, so that you can just have a giant CSV file that you can drag and drop in your own custom domain, your personal joint server. And also, as if you have any questions, just head over to our documentation, or you can go to GitHub and file an issue if you have any issues with that stuff.
Cool. Yeah. So I think that we have a pretty good multi-layered tier of way that people can find out information. So definitely watch our YouTube for instructional information, and we'll try to make a maybe an end-to-end guide. We have in the documentation always examples about how to use things, and then reach out to us however you can if you still have problems, and watch the space so you know when the new joint server is ready. Thanks a lot, Krishna.
Yeah, thanks, Ben.
I'll let you go.
Thanks, everyone. Ciao.
Ciao. All right, so that was Krishna on to answer some really cool questions about the new joint server and how that is going to be able to allow manufacturers to really easily provision devices and then send information to customers who buy those devices so that they can onboard the devices without having to transfer root keys, which should help with like lock-in, and then also just make the whole process of onboarding LoRaWAN devices and transferring LoRaWAN devices more secure. Now I know on the main stage, Adrian is giving a presentation, and that is about avoiding costs as you scale your deployment. So I'm going to cut to that presentation. Let's see if I can find it. Avoiding costs as you scale your LoRaWAN deployment. And of course, afterwards, Adrian will be on to do some Q&A. But for now, let's watch the beginning of his presentation.
Yeah, welcome back. I hope you've been enjoying the Things Conference Spring Global so far. We're going to talk a bit about like how to manage costs. But before we start, I'm Felix, and I have here with me Adrian, who is from the product team. So us from the commercial team, we rope Adrian in quite a lot actually if there's extra questions we want to answer. So he's also the perfect candidate who can help me today to outline a bit what to look out for if you want to keep the costs for a LoRaWAN deployment quite low. So Adrian, I brought you a use case. Quite typical agriculture has always been around in LoRaWAN. So imagine we've had a customer who wanted to start deploying an irrigation system. So let's say there's acres, we need roughly like 10,000 or more devices to monitor the moisture, maybe to control the irrigation system, and a few hundred gateways to actually provide the coverage. What would you look at first when you were looking at costs for such a setup?
Well, the easiest one to start off with is simply CapEx, the amount of money that you're going to be spending on the end devices themselves and on the gateways. Those are upfront costs. You can easily negotiate them with your distributor, and those are generally stable. You're not going to have many surprises there as long as stocks are available for the end devices that you need. Starting from there, you are also going to be needing a network server, and those are again upfront. In the case of us, for our cloud service, you are going to be paying based on the number of end devices that you have registered. You can basically predict how your number is going to evolve over time, so those costs are not very hard to estimate. And starting from there, we get into things which occur only, or rather occur more often at scale. So first of all, when you are going to start deploying so many end devices, so many gateways, you are going to start thinking, okay, those are battery powered end devices at heart. I'm going to need to actually replace the batteries on those end devices. This is going to happen periodically. If you're lucky, 1-2 years, it's a very good start. Sometimes they can do more. But for some end devices, not many, just a couple of them, you're going to have lower times. Those you are going to have to factor in. I'm going to need to send someone in the field to change this specific battery or this specific device in case the device got broken. And you have to factor that this is probably going to happen. Once you go into tens of thousands, hundreds of thousands of end devices, this is a given. It happens, and what you care about is the fact that you can monitor this first, but also take it into account when you look at the feasibility of your project. You should always have a bit of a margin of safety for such events. Another thing that can happen is that your radio signal from the gateways is not as good. So you are going to have to sometimes move a gateway, add an extra gateway. It's not going to be a large percent of your fleet that you're going to have to move around, probably under a couple of percentages, if you have more, even less. But it's important to think about the fact that you're going to have to do those operations at scale. Radio, it's a beautiful thing, but it's also a shared medium, and it changes over time. So what could have started as a perfect signal in an area, suddenly you have people moving near your deployments, they start doing some radio things as well, and you may actually need a new gateway there. Not to replace it, but rather to improve the signal in that area. So those are things that can happen. You can think that you can predict them, but it's good to have in mind that this may happen.
Since you were talking about gateways, like to have sufficient coverage and also battery life, like so if you have more coverage and very sufficient coverage, could you actually save on the battery life on the device? So would you rather have more gateways to have a longer battery life, or less gateways?
Indeed, actually. So the gateways themselves over the past couple of years have gone down in price in general. So the price becomes better and better and better over the years. And you can actually save a lot on battery replacing by having better coverage. LoRaWAN network servers do this algorithm called adaptive data rate, in which, based on the signal strength between the end device and the gateways, they can adapt how much battery the end device uses. So it's going to be a lot cheaper to get one extra gateway and improve the coverage in one part of your deployment than to actually replace 1,000, 2,000, 5,000 batteries 2 times a year just because you had bad signal there. It pays off massively to actually take care and install more gateways while you're at that scale. It saves you more money on operations than it actually does on having people periodically replace batteries.
Which is also a huge reason why we do price per registered devices. Those devices deliver the value. They actually are what we can grow together with, while gateways you can, even from the lowest tiers in the cloud service, add as many as you want. And that's one effect which we've seen became more and more important.
So this is Adrian and Felix on the main stage now, talking about how to avoid costs as you scale a deployment. So I know that they're talking about, for example, in an agricultural use case, and in lots of other use cases that we see really commonly at things industries, how to think from the beginning about how you will basically avoid spending a lot of money when your use case becomes bigger than it is now. And Adrian has seen a lot and works as the back developer at the things industries, so he has a lot of tips, especially for in the architectural side, how to think about things like setting up your LoRaWAN deployment so that battery life is conserved and you don't have to spend a lot of time and energy going out to devices and racing batteries unnecessarily. So lots of good tips like that from Felix and Adrian there. And I have to say hello to everybody who is watching on all the various platforms. So if you're watching on YouTube or LinkedIn, this is the Things Conference Spring Global, and we are talking about what's going on in LoRaWAN in general, and especially at the Things industries. And the way that the conference works is that we are using a platform called Hopin, where we have a couple of stages, and this is the Q&A stage. But I'm showing some clips from the main stage, and if you want to join the conference, there should be a link in the description on the platform that you're watching, where you can jump in the conference, and then you can sit in the front row. You see all of the content live and direct, and you can interact with speakers and ask and have your questions answered. Excuse me. Whoa. And Yeah, so we are definitely encouraging people to jump into Hopin and then to ask your question live. And all of the presenters from the main stage are also, will have some time here on the Q&A stage where we'll answer questions live. So with that said, I will now get back to Adrian and Felix to keep learning about how to avoid costs as we scale our LoRaWAN deployments.
This is already a good estimator for that particular area. It's a good start, and even if you start with 2 gateways and 30 devices, it's still something. It's still, it becomes more and more accurate as you add in devices, but already when you have 2-3 gateways, 20-30 devices, it's already a good start, and you can start looking, okay, this is how much data I've used this month, this one is, if I added more end devices, is going to scale like this, and so forth.
Yeah, so perfect. Like, just sum it up, in our irrigation project, we have to look into the upfront investments, buying hardware, meaning devices, gateways. We can influence the service provision, rollout, okay, we have to install them once. But to maintain it, e.g. battery swapping, etc., that's service costs we can heavily influence with our behavior, so that's ongoing costs. And of course, like the network server is one part of that, which is your subscriptions. That's transparent for registered devices, so not dependent on gateways or traffic on it. But now, yeah, it's not dependent on traffic, but I remember like some afternoons, let's say, of heated discussions in the team. So yes, we do provide a service level agreement. So, right, like we make sure that the cloud service of the LoRaWAN network server is up and running and available from 1 to 1 million devices, however many you would want to add. And that service level protects our customers that we have to provide that service, right? But I know that you could actually set up especially larger deployments in a way that the customer would be in breach with the service level agreement.
Yes, so fundamentally the service level agreement gives you, as a customer, so as one party of the agreement, gives you a couple of guarantees. It guarantees how much the uptime the service is going to be having. It guarantees, for example, how fast traffic is going to be processed, and those guarantees allow you to build an SLA of your own. So you have our SLA, you have our guarantees, you build your own on top of it, and this whole chain of guarantees goes on and on. Now, the idea is that while we are providing those guarantees, we can provide them as long as the customer actually respects his requirements too. So one of the requirements that we have in our SLA is that end devices do not have time synchronized behavior. Now, that's a mouthful. What it generally means is, how we understand it and how we enforce it, is that the end devices send messages at predefined times. So this is not periodical behavior. We are not speaking about the fact that, okay, the device joins at 10:53 in the afternoon and starts sending messages every 10 minutes. That's fine. That's not an issue. The problem is when you have 10,000 end devices and all of them join at the same moment and send messages exactly at the same minute. 10,000 end devices sending a message at exactly 10:30:000, like to the nanosecond. It's a big problem. It's a big problem from multiple points. So first of all, you are hurting your own deployments. So the LoRaWAN runs over radio, and radio is a shared medium. If two LoRaWAN messages occur at the same time, you are going to have what are called collisions. Both messages may actually get lost. So you are going to actually have collisions between the messages that come from the end device. Because of this, the network server is going to say, hey, I'm going to need more messages from your end device. Please send them a couple of times more, and this is going to eat your battery. Because it eats your battery, it's actually going to add your service cost, because now you have to replace your battery more often. So that's something that's going to start affecting you immediately. As you add more devices, the probability of having a collision increases because all of them send at the same time. And that's definitely going to affect directly your costs, but it's also going to disable the SLA from our side. We do not allow this type of behavior, and it's important that while you are procuring those devices, while you are building the firmware, perhaps, maybe because you are collaborating with a company that builds those devices, it's very important that you keep in mind the type of requirements that are going to be in your service level agreements, both ours and of our other services that you may use.
Exactly. So the time synchronization synchronization is one point.
Yeah.
Are there, like, briefly, to at least mention the other factors which seem to be a bit minor than the time synchronization?
Yeah, so second one that's very important is, for example, join behavior. So the simplest example here is some older LoRaWAN devices, in case they had to rejoin the network, so negotiate the keys with the server and start sending your traffic. How they would do it is that they would retry periodically at fixed intervals. So they try now, they try in 10 seconds, then try in 10 seconds again. And what the problem is is that this synchronizes them over time. So let's say something happens to a GSM antenna. The gateway in an area goes down. Now, because the gateway in the area has gone down, all of the end devices in that area no longer have coverage. After a while, because they no longer have coverage, they no longer get any response from the network server, they're going to say, hey, maybe something happened, let's rejoin. And suddenly, all...
So that is Adrian and Felix discussing how to avoid costs as you scale your LoRaWAN deployment. I just did some things in the back end to see if my mic is any better. I know that Adrian and Felix are also in the backstage, and later they will be on here on my Q&A stage to answer questions. If you guys can hear me in the backstage, give me a thumbs up so I know you're there. And yeah, okay, I got a thumbs up from Felix. And is my audio any better? Can you hear me? Sounds okay? Hey, okay, well, I guess probably couldn't get any worse. Anyway, so that is wrapping up the presentation by Felix and Adrian about avoiding costs as you scale your LoRaWAN deployment. For everybody who's watching on another platform now, you're watching the Things Conference Spring Global, and you are watching the Q&A stage. So we also have a main stage in our Hopin platform where that presentation is currently happening. And so this conference is mostly about the state of the LoRaWAN market and exciting use cases, how to scale. And okay, I got a notification that my sound is better. Woo! So, like I was saying, you're watching the Q&A stage of the Things Conference Spring Global. And if you are interested in interacting, in meeting other people from the LoRaWAN community, then we recommend that you look at the link in the description below on whatever platform you are, and hopefully there's a link to join the conference on Hopin, and then you can pester us with your own questions. You can pose your questions to Adrian and Felix and to everybody else from the team, all about LoRaWAN. So that on the schedule looks like it's about wrapping up the presentation about avoiding costs as you scale your LoRaWAN deployment. Also, all of these presentations will eventually be up on YouTube in the next couple of weeks. So even if you can't make it over from your platform to Hopin to see everything live now, they will all eventually be available. So make sure you follow the Things Network on YouTube, and then you can watch this content later. The next video that's coming up is from Adrian again, and it is about corporate integrations. So that is all about integrating the Things stack and LoRaWAN data into your corporate ERP system. And so I'm just going to play Adrian's presentation, and you'll see what that's all about. Oh, I'm not sure if I have this presentation. Uh-oh. Okay, so it looks like we will not talk about Adrian's presentation about corporate IT integrations, but I do have Adrian and Felix here in the backstage, so I'll let them on, and then maybe I will let them answer some questions, and I will see if I can get that video available while they're talking.
Hello, everyone.
So, Felix, Adrian. Okay, here is everybody. Let's see if we have any questions in the chat for you guys. It's not technically your Q&A time, so I don't want you guys to blow all of the good questions already. But in case somebody is curious about something in Q&A. Well, okay, I guess a good way to start is, were there any, can you digest the presentation that you guys just gave about about avoiding costs as you scale your LoRaWAN deployment for anybody who's watching on the Q&A stage right now. And I'll let you guys go ahead with that, and I'll just fix this in the back end really quick.
Yeah. Do you want to start, Felix?
Yeah, sure. I think I'm your student anyways in this process. Like I've learned a lot from you for the last years. Yeah, so I think summing up was like, okay, you have certain costs which you can't avoid, which is buying the hardware, buying the devices. You have to install them at least once, but going forward, you do have actually quite some influence on capping your costs, so limiting your costs. And that there are a few factors which you can look into. That's basically make sure you have sufficient gateways, meaning the more and the better network coverage you have, the easier it will be to maintain battery levels and voltage over time. So meaning you don't have to replace batteries again. Again, replacing batteries requires hands-on manual labor. Your maintenance staff has to go out, technicians have to go out to replace batteries. Very costly, so try to avoid that. And it doesn't even compare to adding another gateway, which is like, of course, it's a capex and an expense up front, but we'll pay back later. Yeah, we talked a little bit about like the SIM card coverage. If you have cellular backhaul, to try to reduce your the period you send messages to a minimum that supports your use case. More information doesn't mean more value, but it does mean more cost, so you can cap that. And we will make you happy because the moment we synchronize our messages, then yeah, our core team will get a little bit anxious. So you can't synchronize your devices. So they have to be desynchronized to be in compliance with the service level agreement, which usually ensures that we provide stable service. But you should, make sure your devices don't send messages at the very same second, like, for example, aligning them around the timestamp, which will, exceed the capacity of our deployment.
Yeah, that would be pretty much the sum up of it. The last point on the synchronization is specifically time synchronized behavior. So having all of your end devices be this large chorus of which sends messages all at once. That's pretty much that's something that definitely should be avoided. In general, end devices should be decorrelated as much as possible in time when the time at which they transmit messages. And while designing end devices, while procuring end devices, you should always make sure that you don't end up having this correlation between the end devices, either intentionally or accidentally. It's something that may look as a good idea on paper when you have a couple of end devices. It would make, let's say, the data analysis quite easy. But once you have hundreds, thousands of end devices, it becomes a really problem to scale. And it's this whole difference between the fact that it worked with a small number and the big difference that occurs when you have a large number of devices, which adds the complexity when you plan those things, and why you have to have a bit of to think of those kind of behaviors ahead of time. And this is why we also have best practices.
Great, yeah.
Read the documentation. That is a good way to start. So we do have a page on the documentation about best practices for devices, which I think you guys you touched on a lot of those, and it sounds like most of the things that you were talking about were really architectural decisions. So setting up your LoRaWAN network in a way where you can just avoid congestion on the network and unnecessary battery replacements and stuff.
Yeah, exactly.
But again, like I said, I don't want you guys to give away all of your information before everybody's here for Q&A. So what I'm going to do is I'll play a little bit of Adrian's next presentation, which is corporate IT integrations, and I'll hide you guys, and then I think your actual Q&A starts in a few minutes. So I'll bring everybody back on once we have some questions in the chat for you guys.
Sure.
All right. See you in a bit.
See you in a sec. Okay. So Adrian is on the main stage right now talking about integrating the thing stack in your corporate network. And so I'm going to play a little bit of that presentation at the beginning, and I'll disappear.
Hello everyone, I'm Adrian from the Things Industries, and today I'm going to be talking about how you can design your IT systems integrations. We are going to talk a bit about what systems integrations are, how you should be thinking about them, and finally some of my tips and tricks about how you should design them. So at heart, systems integrations deal with integrating data between an IoT platform and an ERP system. Businesses have went and spent so many resources and so much time into building those ERP systems that for them it's very important that data reaches the ERP system instead of them having one extra platform to visualize and process all of this data. So instead of trying to replace the ERP system, you should think about how you can get your data inside one of those. IoT data in general needs to be ingested by those integrations and be processed in real time as it reaches almost the ERP system. And you are going to have large volumes of end devices, tens of thousands, hundreds of thousands of end devices, each of them sending an amount of data periodically in general. Due to those requirements, you need to actually think from the start of the scale which your software is going to run. And I'm going to give you some tips and tricks about what you should be thinking about while designing one of those integrations. First of all, everything starts with the API. You are going to need to make sure that the API has a clear specification, or as clear as it possible, on the fields and their semantics, on the messages that are going to be exchanged and when the exchange is going to happen. This is very important. It's the base of your system, and you must make sure that this is clear from the start. Once this is clear, you can start building everything else since you have a good foundation. Now, when it comes to IoT, one of the best ways of designing an integration for IoT is to think in event-driven systems. Basically, you are going to react to events.
That is Adrian on the main stage talking about how to get data directly into your ERP system. And I know he talks a lot about using serverless architecture, about thinking in terms of functions. And luckily, that presentation, I think, is wrapping up on the main stage. I just showed a little bit of it here, but for everybody who caught it on the main stage and is now in the chat, we have Adrian here to answer questions, and Felix is also in the back end. So if you have any questions for Felix, pose them. Adrian, oh, there you are. Let's get you here. Oh yeah, sorry, the video's still playing. Okay, so Adrian, let's see. So can you wrap up in just a few sentences what the presentation on the main stage that you just gave was about integrating into corporate IT systems?
About how you should think when it comes to designing an integration and dealing with other systems. So each time when you're going to deal with another system that you don't control, you should start with your communication. So with the API, have a clear API specification, the semantics, the meaning of fields. That's the best start that you can have. If that one is clear, you're already off to a good start. And then how to design this communication between the platforms. So my main advice is to not try to build a parallel platform or parallel silo to already existing systems within the company that you're working with, but rather try to integrate more and more with what's already in there. And in order to do that, I mentioned this mindset of thinking thinking reactively, of thinking about how you can react to device events, to messages from the end device, and how you can make sure that this scales. So one of the easiest way of scaling this is to actually go into a push mindset in which the messages come to you, go to your system, to your integration, and you react to those messages. And you basically do step-by-step transformations to those messages that you receive. That's the main way you should think about it. Each transformation should be as stateless as possible. So whether or not where your message is processed shouldn't matter. It should be completely agnostic. And finally, you should always monitor your systems. So while you are building those integrations, you should already have this monitoring mindset of how many messages am I processing, how many of them succeeded, how many of them failed, how many of them actually have a success error code, a failure error code. Is there something exceptional happening? Maybe a message that wasn't supposed to be there at all. Those type of things you should be able to monitor at scale. You shouldn't manually go through logs, but instead have an infrastructure built around it. And I mentioned that a very good start is collecting metrics with Prometheus and visualizing them with Grafana, the same way that Johan mentioned in his keynote.
Cool. Okay. And I'm going to bring Felix back on since he's here, just maybe to talk a little bit about the business impact of also of these corporate systems. So Felix, Are you there?
Yeah, I'm here.
Okay. In your work with our client base, do you hear a lot about sort of the pains of integrating with corporate IT systems? Yeah, can you talk a little bit about that?
Yeah. Yeah, I think since LoRaWAN is quite new or comparably new compared to existing infrastructure, IT infrastructure in businesses, there's always a bit of this almost like philosophy to it. Like, do we build parallel systems and we introduce a complete end-to-end solution in parallel to what we already have? Or do we want to integrate it at some point into ERP, into our, whatever existing service, customer service side software? Like there's a lot of these discussions, and that also like increases the overhead of the application, of course, because now you have to rope in multiple teams to make things happen. So yeah, it's definitely a big discussion, and I think it's very interesting that we get more and more demand for Adrian to sit in, or let's say on the passenger seat of these projects to advise. This is what's working. This is what's not working. This is where you can have an eye on in the early stages already. Because for now it could be A or B, but yeah, if you go with A, then it will save you a lot of money later, while you wouldn't see the effect now. So these type of conversations we have increasingly. Yeah.
And how do people get access to Adrian? I mean, what's the best way for people to follow this process of designing these integrations from the beginning?
Yeah, so typically a customer would start on the ThinkStack Discovery. This is the cloud service which we have, which is fully managed by us, and you can start for free with 1 gateway and 10 devices. And once you've done your first steps, you will very quickly see what open questions you have, etc. And then you can escalate to one level and say, okay, I would like to have a support subscription from our support team, which can answer very specific questions on the technical side. They have a lot of experience also with different applications on the past our product, let's say. And then if you say, okay, look, I want to make this proactive, I would like to have regular sessions with Adrian or another core team member, then you can like add a consulting tier to your support subscription, and that allows us to allocate some of Adrian's time to your projects and invest early on so that it scales nicely and cost efficiently.
And do we have resources for people who, I mean, maybe don't need consulting, but want some sort of well-documented place where they can learn from past mistakes?
Yes. So of course we have a lot of content which is going out, right? Like, so if you look for TTN on YouTube, we will find keynotes to many topics. I know yourself, you're working quite intensely on updating and making our documentation even better. So we do have proactive articles on best practices on certain parts of the end-to-end chain. And of course, we launched our, I think last year, our certification series. So you can actually go have a reading list, follow some online courses, and then get like a little, pass a little test and get certified, where we're confident that you've covered the fundamentals or you even advanced or some security related contents. And that gives us already like a really good indication that you've started navigating these topics. We'll give you a massive head start, and we'll make sure that we can use Adrian's time, for example, for exactly the open questions which are specific to your project.
Cool. Okay. So the certification program you mentioned, our marketing team, they asked me also to highlight that because we are doing a sort of competition where if you are a top performer in our certifications program, then you'll get a free ticket to the Things Conference 2022. So that's a plug.
That's the Amsterdam one and on site, or?
Exactly. So in September, we have the big Things Conference, and that's our 5th anniversary. And so anybody who takes a certification and performs at the top will be invited. And then, like Felix said, that's also a great way to force yourself to learn a little bit and to get a good head start in building your LoRaWAN solution. Let me see if there's any other questions in the chat. Okay, it looks like Adrian's answering some questions in the chat here, But somebody asked, what's the best way to ensure coverage when you're just providing them for others to use? I'm not sure exactly what he meant. Adrian, do you know?
Yeah, so how I interpreted the question, at least, is that when I spoke about the costs in the previous talk, we were thinking, I have my own coverage, I own my gateways, and I own my end devices. When you own your gateways and your end devices, you know for a particular device, hey, this is the signal strength for each individual gateway. This is something that you know because you own both the infrastructure and the final end device. Now, this is, let's say, the common use case, but you may also be, as a stakeholder, someone who just has the gateways. You don't necessarily gain access to the particular end devices and so forth. And the follow-up question from that is, how do I know that the gateways that I have in the field are operating correctly? How do I know that I'm actually providing the best signal that I can? Those type of questions come up when you are in the infrastructure mindset in which you have to administer the gateways. And as I also mentioned there are multiple ways to look at it. So first of all, you may have some end devices that very rarely transmit messages such that you have at least a vague idea of how the signal strengths look for certain points in space. Basically, you won't know how it affects the necessarily exact end devices of your customers, but you can at least know, hey, at those positions the signal was this bad or this good. You get a rough estimate for particular positions in space. That's, let's say, the simplest thing you can do. You just get some noisy end devices that send some messages every once in a while, and you look at those. Then you also have events. For each particular end, if all of your gateways are hosted, let's say using the thing stack, you are going to be able to see for each message that particular gateway received what was the signal strength, what type of messages do you get, where do you get them from, and you can do an analysis on that as well. You can find, okay, most of the end devices that I see from that particular network seem to have good signal, which is it's a validation that your gateways are doing fine. They're in good positions. They have good signal. Or it can be the reverse. Hey, with this particular network, which I should be having good signal with because they are paying me, I'm not really having that good of a thing. And you can start a discussion with the operator, with the person to whom you are providing coverage. Those type of functions are going to actually be available probably via the NOC. So you are going to be able to see, hey, I've sent most of the messages to those particular end devices, those prefixes. It's something that can be done with the events that exist in the gateway. And that's a great starting point because it gives you a data-driven approach to how good the gateway is performing, how good the gateways are performing, actually.
Cool. I don't think most people know what the NOC is since Johan just announced it. You want to talk about that a little bit?
Yeah. The Network Operations Center is a new component that's coming up to the ThinkStack Enterprise Cloud, and it's basically dealing, in the first stage at least, with monitoring your network as a whole. So in the first stage, the Network Operations Center is going to provide you very detailed information about how your gateways are doing, what kind of traffic you're seeing, and where is it from, what kind of signal do you have, what's the uptime. And those are already good metrics for you as an infrastructure provider. First of all, most of the time you are going to, the basis of your SLA are going to be your gateways are up and running 99.99% of time, let's say, and this is something that you would be able to easily monitor via the NOC, let's say. Or you are going to be able to see, okay, most of the traffic that I see is from the network that I'm actually having a contract with, so everything goes fine. You can look at the signals there and everything. It's gateway centric in the first phase, and over time is going to get more and more features. Is going to get a lot more tailored.
I think what we see, especially now, is like that this operator model for LoRaWAN networks is decreasing, and that a lot of LoRaWAN networks, new networks, are local area networks, which are set up in factories, in smart city areas, etc. Or if you're a facility management company, that you set up a network for your own use cases, but maybe also for other companies using the same network. So there, yes, you can look into the statistics, but there is also field testers, which you can use to check your coverage on site. So to do a bit of a survey, like it's closer to what you would know from Wi-Fi surveys, etc. So if you do that in a very local scale, and very helpful there is if you do the fundamental certification course. It talks a bit about the physics of
how antennas and devices are set up. So it gives you a bit of an eye of what critical areas to check, right? Because you already see out there behind that in that setup, it might be difficult to get coverage there. So you can just test that set. So it helps you to be a bit more efficient rather than doing a raster test, like checking every few meters.
Okay. I don't see any more. Oh, we have one new question, which is, what are the most common use cases that benefit from LoRaWAN? So any related to smart homes? If so, what could scaling provide for such smart home use cases?
Should I pick that up first?
Yeah, go for it.
Okay, good. So actually, the smart home use cases are a bit different. So what we see in the industry, it's a lot of smart metering. So having a very large amount of meters, let's say water meters, and receiving data from those. What is important there is that you basically use both best parts of LoRaWAN. The fact that it's long range, so with a singular gateway, you are going to hear data from multiple smart meters, and also that it's low power, so you don't have to do as much maintenance for all of those hard to reach meters. You have asset tracking, you have supply chain tracking. Basically, the use cases start from the strengths of LoRaWAN: long range, low power, and wide area as a follow-up from that. When we speak about smart home systems, we basically are having the luxury that the area may not be that big. Depending on what we understand by a house, it's not going to be to the range of kilometers, the area that you have to cover necessarily. It would be. I'm not saying no. I'm saying it's rare. You know, like
Yeah.
if we are going
Only
to think
for
of
really,
scales,
really wealthy people. Yeah.
yeah. Like you doing that at scale, it's probably not as often as you would have all of those cities. Every city having a couple of hundreds of smart meters going around. You know, it's a lot more common when you have to do it at scale, long range, on a very large number of sensors or devices that send data. That's where it shines.
But I think we do see a lot of smart building cases, which there's kind of some overlap with. I
Yeah.
know I've reviewed some thermostats, for example, and there's so many like air quality monitors, things like that. So you can, if your home is very industrial, I think there are lots and lots of use cases.
Or if you want to have fun, it's definitely a good project to have. I recommend it. But yeah, it shines when you can use those long range, low power, low cost actually as well. That's where you get the most out of it.
And then there's one more case that I that we will talk about later in a session with Rish, which is building management companies. I know we have one client who has this really nice closed loop setup. So they have all of these condition monitors in their homes that they manage. And whenever there's a sort of out of spec LoRaWAN sensor data, then they dispatch somebody to go and check the house. So I guess there is this kind of like large scale home automation. I don't know if you call it smart home, but there are definitely sensors which kind of fall into the range of smart home, but are done.
You could definitely do it.
Yeah.
So you could definitely do it. The devices are out there. Definitely. It's something that if you go tomorrow, you look up, you follow the talk that you just gave, and you look up for a couple of end devices. It's something that you could definitely implement successfully and quite fast. It's just that the range is smaller than the most use cases.
Right. So I guess this. Yeah. Go ahead.
It's pretty nice for basements, etc. Because usually, like, you wouldn't have Wi-Fi coverage at scale in a basement, etc. So I'm thinking, for example, if you want to have a leakage detector next to a washing machine or any other sort of plumbing, which is really expensive if it's breaks and you don't detect it for a while. So I think capping these risks. I agree that this commodity of adding comfort to your house, that's not where LoRaWAN shines, because you have other networks there. However, if you are managing a multitude of units, so for example, council housing, or you have you own a building with a lot of units which you want to manage, then we're talking about costs of operating and maintaining such a unit. And there it might be actually quite useful to pop a LoRaWAN network into the stairway and provide coverage for 20 units of that building, and make sure that, for example, humidity is always under a safe level, that mold doesn't come up, which actually reduces the value of the unit and comes with high maintenance costs, which you might have to cover as an owner. And that's exactly the bridge to facility management and building management, where yes, we have operating costs in running facilities like offices, living spaces, etc. So you always have to look into how can I introduce sensors which save me operating costs and add value in that. And that's where typically use cases come up. And once you have a return on invest which is positive, why not to scale it to your entire property, let's say.
Definitely. So I hope that answers your question, Yusuf, about smart home and LoRaWAN. Now there are no more questions, so I will let you two go, and we'll go on to the next presentation on the main stage, which is Hilke talking about how to become a CLI power user. Let me see if I can find the presentation. Here we go. So thanks a lot, Felix and Adrian, for your tips about avoiding costs as you scale and about corporate IT systems. Everybody who is curious, there will be, all of these presentations will be available on YouTube afterwards. So follow the Things Network on YouTube. And bye, Felix, bye, Adrian. And we're going to jump to Hilke on the main stage here.
Hello, and thank you for joining the Spring Global Conference. My name is Hilke Visser. I'm with the Things Industries. Many of you are probably already familiar with our web console, but to scale your deployment, clicking around in the console is usually not the way to go if you want to register 1,000 gateways or 1,000 devices. While at the same time, switching to the API is maybe too big of a step, and that is where the CLI comes in. So in this session, I'll show you how to become a power user of the CLI. I'll begin by setting up the command line interface and then give you some examples on how you can use it to register a lot of devices, to modify a lot of devices, and to become a power user. I'll install and use the command line interface in an Ubuntu 20.04 virtual machine running in the Multipass app. If you install Multipass on your own computer, you should be able to repeat the exact same steps that I'm going to take, and hopefully it will work exactly the same as on my screen. So what we'll do is we'll launch a demo instance with 2 CPUs, 1 gig of memory, and 8 gigs of disk. Okay, with the virtual machine ready, we are going to mount the current directory into the VM. Multipass mount .demo into home Ubuntu demo. And then we'll open a shell in the instance.
So that is Hilke on the main stage.
We'll start by
talking about how to become a CLI power user.
Essentials.
And I know he's covering some really, really useful things for people who are doing LoRaWAN at a large scale. So mostly what his presentation is about is, for example, taking big lists of CSVs of devices and adding all of those devices using the command line in the thing stack, or making a bunch of devices claimable. He gives a really, really good example for that. And then, so as a device manufacturer, for example, you can take a big list of information about devices. You can onboard those with just a simple script in the thing stack, and then you can create a bunch of QR codes which you can send to all of your customers who buy the devices in order to allow them to onboard devices really easily. And then he also gives a script, so if you want to claim a bunch of devices. So just all of these really enterprise-focused tasks, Hilke is covering how to do those at scale and in an efficient way as a CLI power user. You are watching the Things Conference Spring Global. I just want to say hello to anybody who is dropping in suddenly on any of the other platforms. We're here on the Q&A stage, where I'm showing a little bit of content from the main stage, and then I'm also bringing all of the people who have presented on here to answer questions. And the conference itself is hosted in Hopin. If you're on another platform like YouTube or LinkedIn, there should be a link in the description where you can join the real conference, and then that way you get to see all of the content live, and you can also ask questions to the presenters, which we will answer live on here. Linked in the description below, you should also see the Things conference, which is our big conference which we hold in September. That is, it's going to be our 5th anniversary this year, and we have lots and lots of really cool and exciting information and presenters to talk about the state of LoRaWAN. So check out the Things conference in September. I think I will give it back to Hilke to continue to talk about how to become a CLI power user. So here's Hilke back on.
And if you haven't logged in yet, it will ask you to log in, but I'm already logged in, so I can now copy this authorization code and back in the terminal, paste that, and it looks like we are logged in. You can verify that by running the ttnlw CLI auth info command, and that will show you who you are and what rights you have. Another way to log in is with an API key. That way you can you only have to log in once, and you don't have to renew your authorization after you log out. So let's create an API key. We do that for our organization, my org. It works like this: ttnlw CLI. We'll give it the right to create applications in my organization. We'll give it the right to list applications in the organization. And we'll give it all application rights. Okay. Now we can copy this key and again run the login command, but then with the API key flag set to that API key. Again, we can run the auth info command, and we'll see that we are logged in now as the organization. Before we move on, I wanted to give you a few tips for using the CLI effectively. First of all is use the auto-completion and the suggestions that the CLI gives you. So whenever you type ttnlw CLI applications list and then start typing something, you can press tab and it will show you the possible things. So in my case, I want to select the organization ID and it will auto-complete that, and that was my org. And then we see that we don't have any applications. Another thing, when you use the CLI, it is very useful to combine that with the JQ tool that we installed. So let's take a look again at that auth info command. We can pipe that into JQ. We can use JQ to select a field that is in this object. Yeah, next, using colors. The CLI has some colors for the log messages that it throws. I like to see those, so you need to export color term is 1. And if you want to have that persist, you can put it into your bash or C in my case. Finally, if you, like me, like to type less, you can also shorten a lot of commands. And even what you can do is shorten the entire CLI command. So that way you don't even have to type ttnlw CLI, but you can maybe alias it to TT. So I can say tt app ls, and that basically means the things ttn lw CLI applications list. It's much shorter. Moving on. What we came here to do was create entities in bulk. So imagine that you have a database of entities or a CSV file. You might want to create those all at the same time in one go instead of having to click around the console and create them one by one. So I prepared a CSV file with applications that we'll create and another CSV file with some end devices that we're going to create. Yeah, like I said, often this information comes from a database, so we are going to treat our folder.
Sorry to interrupt you, Hilke, but we have a Q&A with Hilke coming up here pretty soon, and so I just want to make some announcements before we bring Hilke on. If you are interested in following along with Hilke's entire workshop about becoming a CLI power user, then follow us on YouTube, and there we're going to post the whole video and then also all the code, so that you can borrow all of Hilke's awesome tips for working with LoRaWAN devices at scale. We have, like I said, Q&A coming up in a minute here. I'm going to bring Hilke on, so if you have any questions, feel free to ask them. And anybody who's watching from any other platform, just so you know, you're watching the Things Conference Spring Global. This is the Q&A stage. The entire conference is happening in Hopin. And if you're in Hopin, then you get to see all the content live on both stages. You can sit in the front row. You can interact with speakers. You can ask questions, which we will bring guests on here to answer. And you get to meet other people from the LoRaWAN community. So if you're interested in developing with LoRaWAN, the Things Conference is definitely the place to be. And there should be another link in the description below to join the Things Conference Spring Global. Now, it's not too late to join this conference and ask your questions. And then also, we have our big conference in September. The conference in September is our 5th anniversary of hosting the world's largest conference on LoRaWAN. So yes, that's the 22nd and 23rd of September in Amsterdam. It will also be virtual. We have a huge list of partners and lots of cool surprises. And we'll talk all about digital transformation in the field of LoRaWAN. So we're going to discuss LoRa Cloud. We have lots of exciting small presentations about things like LoRaWAN multicast, and then also really cool vertical and use case analysis. That is the Things Conference in September. And we have also, we're always trying to put out as much educational information about LoRaWAN as possible. And we also have our certification program. So at thethingsnetwork.org, you can go and you can learn lots and lots of cool stuff about LoRaWAN. You can learn about the specification and how to actually create LoRaWAN solutions. And then we have this certification program where you can test your knowledge and you can demonstrate it. And all of the top performers in this certification program, we invite to the Things Conference in September for free. So if you're interested in learning more about LoRaWAN, please head over to thethingsnetwork.org/learn, check out our certification, and learn all about LoRaWAN. We also have a series of webinars that we're going to be doing all year. So on the 19th of May, we have a conference or a webinar on YouTube about agriculture. And then on the 2nd of June, we have a logistics-focused webinar. All of the details about everything are at thethingsconference.com. So if you want to know more, head over there. Next up, we have a Q&A with Hilke, who just had his presentation on the main stage. And Hilke is in the back stage here. Okay, Hilke, I'm bringing you on, and we're going to ask you some questions. Here is Hilke. Okay, let me hide this. Hello, Hilke. So can you sum up what you shared on the main stage for us in maybe just a sentence or two?
Yeah, sure. So I showed how to use the command line interface of the Things stack. It's a nice little tool that allows you to script things locally. Maybe you want to do many operations on many devices, on many applications, or whatever. Then clicking around in the console is too much work, but with the CLI you can type a few lines of scripting and then run that for all your devices at once.
Okay, and something that I just realized from talking to Krishna is that the examples that you gave for device claiming, that device claiming process is going to change when the join server changes. So can you talk a little bit about, I guess, how people should look towards scripting and automating these tasks as we roll out new stuff in the thing stack, like the new join server, the knock, the notifications?
Yeah, sure. So these things that I showed in the presentation are, of course, just examples of how you could use the CLI. There are maybe many other operations that you might do. So some time ago, I wrote a script for transferring the things indoor gateways from v2 to v3. And yeah, those are those little tasks that they cost a lot of time if you had to do them in the console. But with a script, you can just run it for 1,000 gateways, 1,000 devices, or whatever. And the same goes if we later this year launch the things join server, then you might still want to mass update device configuration for your entire fleet. Maybe you want to add some attributes to your devices. Maybe you want to update payload formatters for a specific group of devices. Those are things that you, of course, can do in the console. But by doing them in the CLI, you can do it for 100 devices or 100 gateways all at once.
And I guess a big part of the presentation is that a lot of people are a little bit afraid of the CLI. Do you have any recommendations for people for sort of getting started with scripting?
So we have a couple of examples on the documentation website. So the entire first part of the presentation is just basically following the getting started guide that we have on our documentation site. So go through that. I've shown you the JQ tool. So that is a little tool that operates on JSON documents, allowing you to transform them. And by using the pipes in Bash and other things like that, you can get the output from one command into another. So play around with that. You can maybe start sorting a document or filtering something in a list of devices, and then you just iterate. So you start with a little one-line command, and then you compose that together with other commands until you have something bigger, a script that you want to do. And that is also what I did in the presentation, right? So I started with just showing what the output was of I don't know, getting something out of the database, and then transforming that with another command to then pipe it into the CLI in order to create the devices. So start small and then make it bigger.
I know when I want to learn something, I usually look it up on YouTube, and so I think it's really nice if we have guides like you made where people can follow along and actually try to do these things themselves.
Yeah, and I'm curious to see what other people build. So if anyone from the community has built a nice script or tool that uses CLI, please let us know. Also, please let us know if we can make any improvements to the CLI to make it more useful to you. You can create an issue on GitHub if there's something wrong with the CLI or if it doesn't behave as you would expect. So please let us know.
And we're going to wrap your example up and share all of the code on YouTube, I believe, afterwards. So anybody who wants to be able to follow along with Hilke's workshop, just follow us on YouTube, and the video will be coming soon with a gist, I think, so that you can copy and paste a lot of stuff. Doesn't look like there's any more specific questions. So somebody asked, Adrian said that rightfully monitoring is really important. I use Prometheus and Grafana, but how can I monitor my gateways? All I was able to get from the CLI is the time of my last message transmitted through the gateway. Is there a way to check if the gateway is up and running even when there are no messages flowing through it?
Yeah, so actually what you can do with the CLI is the same as what you can do in the console. So there are commands to get the gateway connection stats. So yeah, just look in the documentation of the CLI and you'll find that command. The CLI can also work with the event stream. So if you go to the console, you can see the live view of events that happen on your gateway or on your application. You can receive the same events in the CLI and then process them. Yeah, again with JQ or some other tool, you can put monitoring on that and trigger an action if some specific event pops up. So yeah, you can definitely use the CLI for that as well.
Cool. So hopefully that answers your question, Helmut. And it looks like that's the end of the questions that we have for you. Okay. Thanks for your time and thanks for sharing all of your knowledge about becoming a CLI power user.
Sure. Thank you as well.
I'll let you go and with the next presentation. See you. Okay.
Bye.
That was Hilke Wisse, who is one of our backend developers, and he shared how to have really useful tasks in the. So the CLI is kind of this perfect balance, he says, in between doing things in the console, which is very graphical, so you can move around and everybody's pretty familiar with the console, and it's very easy for doing things one at a time. But as soon as you get onto this enterprise scale of, say, having hundreds or thousands of devices, then you don't want to have to click and do things like that anymore. And we do also have an API in the ThingStack, which allows you to integrate it directly with basically anything. But the CLI is a nice intermediate where you can script a lot of really useful and important tasks. And so Hilke's presentation was all about modifying end devices in bulk. We will share that on YouTube. Follow the Things Network on YouTube if you want to be able to follow that. And what do we have next? We have, it looks like Helmut, he's going down into this hole of trying to figure out when a gateway is connected. And that's a very, very interesting, it's a very interesting problem, which I think we do a lot of, we have a lot of different ways of updating that information in the console. So you have to follow up with us later in order to figure out how that really works. But it also makes a big difference whether it's a UDP gateway or a basic station gateway. So I don't think we can answer that question completely here, but please follow up, send us a message, and we can explain more about that. Next up, we have Felix and Rish to talk about different ways of deploying the ThingStack. So I'll pull that video up now. Here we go.
Thank you, Ben, for introducing us, and I hope you've been enjoying the Things Conference Spring Global so far. My name is Felix.
I'm Rish.
We're from the commercial team at the Things Industries, and we're going to cover deployment options today. Before we dive into options, Rish, what are we actually deploying?
Yeah, I think it's good to first understand, what are we talking about when it comes to deployment. So let's take a look at any LoRaWAN use case. You have four main components. You have your end device. So here is an example of an end device. This is a generic node. You have the gateways, LoRaWAN gateways. Here's an indoor gateway that we have. And the third component is the network server, which is what we're going to talk about, how to deploy that. And the fourth component is the application server, which typically you use it for dashboards or you use it for visualization or analytics. But what we're talking about here is the network server. So by now, I'm sure you know what a network server does. And in this session, we're going to talk about what are the different options when it comes to deploying it and which one is suitable for which scenarios.
I'm sure if you've been on the website, all of you have maybe had a look. There are different deployment options listed. We've done some branding on it. So we talked there about cloud and enterprise. Could you help us map this a bit? Like what is behind these names?
Yeah, so when you talk about deploying the network server, there are two main ways of deploying this network server. The first one is called a managed service, and the second one is called self-managed service. So the main difference, as you can tell, between managed and self-managed is who has access to the infrastructure, who is managing that, and this is how we differentiate these two options. So what you see on the website, you have the ThingStack Cloud, and you see the ThingStack Enterprise. So ThingStack Cloud is part of a managed service where we, as the Things Industries, we host the stack, the network server on our infrastructure, and you or any other customer, they use the service as it is. So this becomes like your typical SaaS model where the software runs in the cloud, on the vendor's cloud, and you or any other customer, they just use the service as it is. There are different ways of payment which you can see on the website. So this is covered under managed service. And then you have the second part, which is the ThingStack Enterprise, that's part of self-managed service, where the customer, they run the stack on their own infrastructure. Now, this own infrastructure can be their own cloud, can also be locally on site, or can also be on gateway. So there are different options. For most of our customer base, they run the network server in their own cloud or on their own local machines. So that's the second way of running the network server.
What we really wanted to cover as well is if you're getting started, right? Like now, so we know now what is the network server. It's the ThingStack. We can deploy it as a managed or self-managed service. Another question is we are getting a lot is how do you get started? What's actually the better way to get started? So from our experience, we would advise you to start always with a managed service, even though for the later deployment, like when you really roll out your use case, the self-managed service might be the better option. There are a lot of criteria which we can cover in a bit. But if you start first with a managed service, and of course we believe in that this is a sustainable model to use later for your production deployment. But for your proof of concept, for your first prototyping, start with a managed service. It allows you to shift a lot of the responsibilities to us at the Things Industries. We make sure everything runs. We make sure everything works from one registered device and one registered gateway up to thousands or even 10,000.
That is Felix on the main stage, just finishing up, talking about the different ways that you can deploy the Things stack. And I know that him and Resh are addressing a lot of misconceptions about, for example, security, about privacy, about costs and more. And the last thing he said there is that we always recommend that everybody use a managed service because your job is not really to run the backend that it takes to run a LoRaWAN network server. And so using a managed service like the ThingStack Cloud, which we host on our infrastructure and then you have access to, allows you to just concentrate on doing what you do best, which is using your LoRaWAN data. So we have Felix and Rish here for Q&A. Is there anything else that I need to say before I bring them on? Let's see if I can see them in the back end. Okay, I know I can see Rish here. If you, the same things I've been saying, which is that for anybody who's watching on another platform, this is all happening in Hopin. So if you're on YouTube, if you're on LinkedIn, check the description below for a link where you can actually join and Hopin, and then you can have your questions answered live. So I'm going to bring Rish on and potentially Felix as well. Here, let me hide this video. And hello, Rish. Hello, Felix.
Hey, Ben.
Hey. How you guys doing?
Doing well. Doing well.
Cool. Can you sum up quickly what some of the takeaways from your presentation there, Rish?
Yeah. So we're talking about deployment scenarios, and most often, there comes a point when people ask, hey, which deployment option is best suited for me? And I think the summary from our session is that in most of the cases, the ThingStack Cloud is the one that we recommend. And the reason for that is we manage the network server, we take care of the hosting, updates, anything else that comes around with it. And then you, as the customer, you just get a managed service, SaaS service, and you don't have to worry about maintaining or updating the network server. You can actually focus on your business case or your unique proposition. So that was kind of like the main summary, that the Things Like Cloud is indeed what most of the customers should be going for, and the fact that the Things Stack also has flexible deployment scenarios. So depending on your use case, we do have support for that. But the message was the Things Like Cloud is the one to go for.
And what do you think are some of the reasons why people might think they would push back against that?
I think one common misconception is that if they do an on-premise setup, or let's call it self-hosted, that they have more control, they have more security. Control part, yes, they do have more control over the entire deployment because they then run it on their own infrastructure. But security-wise, I mean, it's still like, yeah, if you're running it with some less resources and you don't really know how to manage it, then it might be prone to more errors. It might be prone to breaking up. So in those scenarios, you're better off with a managed service than doing it on your own, because unless you are like you have a dedicated team which can manage a network server, you're better off with someone else handling it. So that is typically one of the misconceptions that we hear quite a lot. I don't know, Felix, if you have something to add on that.
Yeah, yeah, I think because we do have a quite large community on the Things network, which has shared infrastructure. The point is that the Things Like Cloud is your private network, so nobody has access to your information, even though you're using a shared cloud infrastructure. That means your messages are still encrypted. The gateway coverage is private to you unless you choose to open that up through services like Packet Broker. And yeah, there's just no setup fee, right? Like if I have to run my own machine, I have to install it, I have to configure it, I have to so just like the process of getting my first devices ready to connect is way longer than just signing up to the Things Stack Discovery free of charge, getting started, learn your ropes around your use case, and then you can still look into what managed or self-managed service is better for me in the long run.
Yeah. So you would say, if it's possible, definitely start with a managed service and take things one step at a time. I think that makes sense to me too. You don't want to try to conquer DevOps and whatever your business case is at the same time. So if you can avoid that, then let us take that hard work. We do this full time. So running a LoRaWAN network server is something that we're really, really good at. And whatever your business case is probably something that you're better at than we are. So concentrate on that. I think that's the takeaway.
Yeah,
there.
absolutely. We would just do it at scale, right? Like we do it for so many people at the time, so we can offer it as a lower overhead than you could do for yourself.
Right.
And it's also
we can
like
do it more efficiently.
This whole flexibility, right? Like, so for instance, if you are in the early stage of your project, I mean, you don't want to add on unnecessary tasks of running and managing a network server. So maybe in the initial stage of your project, if you are just there to do like a small proof of concept with, I don't know, few devices, 10, 15 devices, you don't really want to host the network stack on your own. Maybe you go with a cloud solution, and then once your POC is successful and you have a go ahead from your end client, you can either continue on the cloud, or then maybe you can, if a customer is persistent on running it self-hosted or running it on premise, you do have the option. But let this not become the first problem that you tackle. Is the lesson here.
Yeah.
Are there any definite no-goes for using cloud or using on-premise?
Not per se. I mean, like what I said, I think in the beginning stage, it is always good to first like validate your POC. And again, as a company who's trying to validate your POC, you want to really do this as soon as possible, or as fast as you can. And then in this way, you have the Things Like Cloud. You don't have to worry about any of the hassles that come with managing a network server. You just get it managed by us. You have the devices that you can buy from a lot of these distributors out there. You have the gateways, and off you go, right? So it really lowers your cost of operation in the beginning and throughout the project. That's something. And then, of course, if at a later stage they want to migrate, there is always an option. But there's just one quick thing is that people always come, no, I want a self-premise because that's all I have used throughout my business career. It doesn't really work in that sense. So yeah, that's kind of like a the lesson I would say to watch out for.
Yeah, to be willing to embrace change if it accelerates your growth.
Mm-hmm.
Yeah, we see a lot of private networks which grow to a size where it was easy to maintain your on-premise network server at first, and now the overhead increases, and then they're looking to migrate, which is okay. And maybe they come with certain additional requirements. After Brexit, there was a huge push for having a cluster in the EU. And we're a flexible company, so we're always happy to accommodate requirements like that. So we spun up a second cluster. One is in Ireland, one is in London. So yeah, latency is low for both if you're based in the EU, but then we can also ensure that your data never leaves the legal entity EU, and you can be compliant with some of your data policies, for example. So challenge us, write us an email at sales@thethingsindustries.com and ask for what you are missing at our service. And as we evolve, I'm sure we can accommodate a lot.
Cool. It doesn't look like we have any other questions. There's one about, so for a corporate installation, what is your feeling if they require a private gateway, or are they open to use public infrastructure? And I guess it has to do with whether the data is secure if your data travels on a public network.
Yeah, I think it's your data even is secure. So if, for example, you used your private LoRaWAN network server like the ThinkStack Cloud, and you used another public network via a packet broker, your data is still, all the messages are still encrypted, right? Like, so your information is private to you. However, you don't have control over the maintenance and operation of the network infrastructure. So if a public network member is taking their gateways offline, you don't have any claim that this should be maintained and up and running, right? So you are running a bit of you're gambling a little bit with the availability of the public coverage. And that's why a lot of customers come to us and say, okay, we want our private network, because then we can ensure quality of service together with your service level agreement and our operations.
Sure. But I guess packet broker kind of provides a little bit of a way to do both, right? You can manage your own coverage, but then share it or sometimes benefit from other people's coverage.
Yeah, exactly. And then it should be as a redundancy, right? So it should be, if my gateways go down, then I could use a community gateway if it's within reach. And in return, the community benefits from your private network gateways, which are usually most of the time online, right? So it's a quid pro quo. It's synergies we're using between these two worlds, or which we try to foster.
That makes sense. Cool. Thanks, guys. I don't have any more questions for you. I think we'll jump on to the next presentation, and I'll let you go. Thanks again for all of your knowledge. For everybody who wants to follow up with us, you can also see all of these presentations later on the Things Network YouTube, so please follow us on YouTube and send us an email anytime if you have more questions. Thanks, Felix. Thanks, Rich. I'll let you go.
Thank you, Ben. Have a good one.
Cheers. So the next presentation is me and Rish, and it is all about a question that we get all the time, which is, what is the right LoRaWAN device for my use case? So we have a few videos on YouTube comparing lots of different LoRaWAN devices, and this is a little bit of an extension. Usually I do those comparisons, but this time I roped Rish in because Rish sees a lot of customer use cases, and so he talks about all of the situations that these devices are actually used in. So I'll roll to the video now. And this is the 7 most popular LoRaWAN devices and how they are used. So I'm just pulling that up here. Here we go.
Hello, Rish. How are you doing?
Doing good. How about yourself?
So we are here today to talk about some of our favorite devices from the LoRaWAN ecosystem and to talk about some of the really interesting ways they're being used, right?
Yeah, so today we're going to talk about the most commonly used devices and also cover or touch upon a bit on the business case as to how these devices are used by commercial businesses, what benefit it brings, and why do some devices stand out from the rest.
Awesome. And we're doing this interview remotely. So I'm here in Berlin and you are...
in Amsterdam.
Cool. This is exciting. This is a fun way to do this. Everybody bear with us. Hopefully this goes smoothly. So today we're going to talk about a couple of devices. The Laird Centrius RS1, the temperature sensor, the Elsys EMS sensor, the Elsys ERS CO2, I believe. We have the Dragino LHT65, a Sensatera soil sensor, the Codec cow tracker, and then an Eltron water meter. We'll go through all these devices one at a time, and Rish will share some of the cool use cases for the devices. Let's start with the Laird Centrius RS1. The RS1 is a temperature sensor, and it comes in 3 different flavors. Low temperature, then there's a mid temperature, and then there's a high temp model that measures up to 450 C. The device is about 10 centimeters by 10 centimeters.
Yeah, so this device is one of the most common devices that we see across our customer base. In essence, it's a very simple device. It does temperature humidity monitoring. The unique thing about this device is that it is quite industrial, it's ruggedized, and for certain use cases it even has an external temperature probe, so you can attach it and use it in industrial fridges or use it in cold chain monitoring. It's really easy to use, so you can just connect this device and you can forget about this. The other aspect is that this device is available for the European band, US, North America and Australian band, so you get the full global coverage with this one device. Simple device, easy to use, and that's the Laird Centrius device.
Next, I wanted to talk about the Elsys EMS. So that is a small sensor from Elsys, the Swedish company, I believe. It measures temperature, humidity, and has an accelerometer. And then it's also marketed as doing leak detection.
Yeah, so this is a really small, compact device, and it can support a large variety of use cases. So of course, it can be used for simple use cases such as temperature, humidity monitoring, occupancy, door window sensors. So the use cases list is endless. And just like the other device we covered earlier, this device is also available for European, North American, Australian, and a wide range of other frequency plans. So we see this use case in, again, the most common one is again in the monitoring temperature for vaccine. That's one of the big use cases, especially with this device. But we also see this device in a lot of buildings where people use it for conditional monitoring, and in industrial buildings where they use it for, again, monitoring the environmental parameters. It's again quite a common device.
Okay. Yeah, vaccine monitoring sounds like it's pretty topical.
Especially with this one, because you can put it like these vaccines. It's good that you mentioned this. So these vaccine storage, they are done in these underground storage where you have these large fridges. And because this device has a really good antenna, you can put this device inside the fridge, and then its range is so good that these gateways that are placed inside the buildings, they're able to pick up the messages from these devices. So that's another aspect to look at this device, that you can put this deep inside the fridges and you're still able to collect these data from these sensors.
An advantage of having such a powerful communication technology like LoRa.
Yes.
The next device that we're going to talk about is the Elsys ERS, Smart Building Sensor.
This device is deployed a lot in the social houses, so particularly in the UK, also in a lot of areas in Europe and also Australia. And the use case that we see is in a lot of houses, social housing, you need to monitor the conditions of these houses. We see sometimes mold, damp, and these conditions change. So with this device, you're able to monitor that, and in case something goes wrong, you're able to also send someone to fix that particular problem.
And I think you touched us on something we like to really highlight, which is this integration of sensor data into actually actionable business processes. Tickets are actually created based on the data that comes from these sensors. Maintenance, for example, is done based on anomalies in that sensor data, right?
Quite an important topic. I mean, we see that a lot of times people, they buy these sensors, they connect them, they have a dashboard, and then they think that they are solving a big problem. In our opinion, or at least what we see, the use cases that are successful, they always have a business positive use case. And what I mean by business positive use case is if you're measuring temperature, humidity, and if you're just plotting it on a graph on a nice looking dashboard, it might look nice, but then again, you're not doing anything based on that data. But for instance, if you are getting the same temperature humidity readings and you are fitting it, or you have a closed system where if something happens, then you have a person goes in, checks in, and then it becomes a closed loop system. These are the use cases where we see businesses making an ROI on their investment by using LoRaWAN devices, and these are the use cases that actually scale. So a suggestion or from our side would be that look out for use cases where you actually have an action based on the sensor reading that you're getting.
And those ELSys devices, I did a review of one of them this year, the ERS CO2, and that measures temperature, humidity, light, accelerometer, and CO2 in the air, and it's about 8 centimeters by 8 centimeters. The ELSys devices I really liked because they have a really nice app for configuring things like traffic lights and keys. The app is really well designed, and then they have a really good battery life and a nice calculator online where you can plug in exactly what your conditions are, and then you can see exactly how long the battery should last. The next device that we have on the list is the Dragino LHT65. I did a review for one of those as well, and one thing that I noticed is that it looks like it's very easy to mount on something. It has these great screw terminals, has great battery life, and then also does temperature, humidity, and has an external probe where you can attach a variety of sensors that Dragino produces.
Yeah, so this particular device has been there for a long time. I mean, I've seen this device, I think, for more than 5 years now. And there's one thing about this device, that this device is used in the masses, right? As you can clearly tell, this device is very simple. There isn't really a lot of special things going on. It does one thing which does it really well, and it's low cost, so people can buy it in bulk. And from our side, where we see this device used is especially in retail and these fast food restaurants, where they need to monitor their meat, they need to monitor their food supplies, and they have so many different sources from where they get their food supplies. And in order to monitor the temperature levels, you have a very easy, cost-effective device which you can put it, forget about it, and it keeps sending your temperature readings. So simple, but works, and it's really effective device.
Next up, we have the Sensoterra soil moisture sensor. They make this product in a variety of depths. It's very, very easy to install. It's literally just stick in the ground.
Yeah. So this device is also it's one of the old devices, but still it's quite effective. And it's again, at the end of the day, it's a simple device. It does soil moisture monitoring, and for a farmer, especially when you have big farmland, connectivity over there, 2G, 3G, or any type of wireless connectivity, it's quite difficult or challenging to set that up. But with the LoRaWAN device, especially the one from Sensoterra, you're able to monitor the soil moisture levels across your farmlands with this simple device. And as Ben mentioned, it has different depth levels, so depending on your crop, depending on the region that you are in, you can adjust the height. It's easy to use. We have the support for this device using the device repository, so you can add it. And we have several customers in Canada, US, Australia using this device and making their operations quite easy. So simple device, easy to use.
One of my favorites, the Codec cow tracker. And I have written from the notes that it's compatible with cows, horses, wildebeest, and reindeer. So not just cows. And then it's also Arduino compatible, so you can make upgrades, and then it's also solar powered.
So this is, I think a lot of people who have tuned into the Things conference before, they would have seen this device being used by Movement, one of our customers in Australia. But besides Movement, there are also a lot of other projects where this device is used. And as you can tell, it's a simple device. It tracks your cattle, and again, for the most part, it is used for tracking cows. But as you mentioned, it can also be used for tracking buffaloes, horses, or you name it. The reason why this device is so common is, again, for a farmer who has a big farmland, tracking your cattle can be quite a tedious task, especially in Australia, where these farmlands are so huge. There is literally no connectivity. So to make sure you have insight as to where your cows are, where your cattle is, and being able to geofence that makes it quite a compelling device. The form factor is really attractive, And it is also suitable for these harsh environments. And then again, because it also has, it can be powered through solar, you don't have this hassle of batteries. So keeping in mind all these factors, this makes it an extremely useful device for a farmer. And this is again why this device is showcased here.
Being able to track your livestock from your phone, I think is very, very, very useful for farmers and allows them to sleep peacefully at night, knowing that their cattle is where they expect.
Peace of mind.
Yeah, that's priceless. The last device that we have on the list here is the Eltron smart water meter.
So every household that you do in Europe particularly, there is a bit of this transformation where companies or households, they're moving from this manually taking the readings to having an automated way of taking these readings. And as you can imagine, if you have to go to each and every household and collect these meter readings, it can be quite a tricky task. Forget about like the whole logistical operations that you have to carry out. So for a lot of companies involved in this particular space, especially the city councils or system integrators in between, for them having this device which you can put it up on your water meter, collect the readings, takes away the whole hassle.
That is Rich and me talking about the 7 most popular devices in the LoRaWAN ecosystem. Oh, let me see if I can hide it. And yeah, so that is it's an extension of a popular video that we have on YouTube where we compare different LoRaWAN devices based on a particular use case. And Rich has a lot of expertise about the use cases for these actual devices. So he sees customers who actually use them, and he's providing a lot of his knowledge about what those devices are used for. If you are just joining now on another platform, you're watching the Things Conference Spring Global. This is the Q&A stage. Right now, it is supposed to be Q&A with me. So I will go here into our Hopin platform where we have some questions, and I will see if there's anything to ask or answer. So it looks like we have some questions about devices. Somebody's asking particularly if there's a way to measure down to -80 degrees Celsius. I've seen the major part goes down to -55 degrees. And so I assume this question is about the Laird RS1. And Laird, I know, has 3 basically models of their temperature sensor. So they have a really low temperature version. Then they have a medium temperature version, and then they have a high temperature version. Let's see. Okay, Rich, I see you in the backstage there. We don't have any. Let me see if there's any questions. Okay, questions about recordings. Yeah. Also, all of these will be. All of these videos are available on YouTube afterwards in the next couple of weeks. But if you want to see everything live, then check the description in the link below if you're watching on another platform, because everything is live in Hopin on the main stage. So what you're seeing down here in the corner is a clip from the main stage, and Rish is here in the backstage. So I'm going to let him on to talk a little bit about what we just talked about.
Hey, Ben.
Hello. Oh,
right. Can you hear me? Yeah.
I can hear you. So yeah, we just talked on the main stage about 7 of the most popular devices in the LoRaWAN ecosystem and how they are used. What do you want to? Well, I cut off the video before the end, so maybe if you can share your 3 tips that you gave at the end there for people who are looking for a LoRaWAN device.
Yeah. So yeah, I think the 3 main takeaways from that session is there are lots of LoRaWAN devices which are out there. So first takeaway is check them out on our device repository, check them out on our marketplace. We have a whole range of several verticals. So chances are that if you have a LoRaWAN use case, we probably have a device that is easily supported. So you can just pick off-the-shelf sensors. Second of all, make sure that the way you are procuring this device and the way you are adding this device onto your project is all secured. And I think we talked about already a few sessions on how you can do that. And third, and the most important takeaway from all of this is make sure that sensor reading from any LoRaWAN use case that you're working on is actually being fed into your business use case. And I think this is something which you may have, which you may recall from the session earlier, that the most important thing is when you have a sensor, it's not just to see the sensor readings on a dashboard or like a fancy looking graph, but the whole objective is that it feeds into a closed loop system. It feeds into the business logic where there is an action step based on the sensor reading that you have. And I think these 3 tips, if you follow them, I think you will get some success with your LoRaWAN project. Would be my take on that.
Yeah. So the tips were from the video. I remember your tips were to make sure that you can securely, not securely provision or get the device, but in the future that the supply chain is available.
Yeah.
And then also, like you said, to make sure that you have a business positive use case. And I think that I want to hammer on that again. So like you're saying, the use cases that we see that really thrive, that are scalable, that continue on to live, are ones where there are actions and business processes that are driven by LoRaWAN data. So collecting data is one thing, but making sure that you have a closed loop where one example that we gave in the video is, for example, there are temperature sensors in these buildings, and the housing company creates a ticket and sends an employee to go and check on this building if one of those sensor readings is out of data. And so as soon as you have this situation where you've taken a human out of, well, you've initiated a process based on this data, then you have a business positive use case, and that's where we really see people driving ROI.
Exactly. Yeah. I mean, these sort of use cases, so like what you said, exactly, like if something is wrong with the social house or any house in particular, and you have a sensor put in there, and if you're a solution providing company, then the sensor value should actually feed into your business logic that, hey, if the temperature, I don't know, if it falls below 25 degrees or 20 degrees, then you have an inspection person who goes out or does something, so you have an action which is created based on the sensor reading that you have. If you just plot it on a nice graph, it looks nice, your teammates might be happy, but beyond that, it really isn't doing much. And another example, like if you're talking about social housing, is if you go to like US, for instance, you have a lot of these boilers which are situated in the bottom of the buildings. And sometimes these boilers, they break down, or something is not right. So a very quick action step is, if you have a LoRaWAN sensor and you see that there is an anomaly with your boiler, and if that sensor reading is just showing on a graph, you see that, okay, the boiler is not working. But if that same sensor information is fed into your business logic that, hey, if the boiler is not working, you send your electrician or a mechanic there. Now that is really adding value to your service. And that's what kind of like the focus is, that there are a lot of devices available in the whole LoRaWAN ecosystem, but also the message here is that try to make it a business positive use case. So now in these 2 examples, you saw that if something was off, there is a business process that takes into account, and then you have an action that is created on that. So kind of along those lines,
Yeah. I don't think that there's any other point that I want to drive beyond that. Thanks for coming on, Rish. Let's see. Are there any closing remarks that you want to give? This is one of our last presentations of the day, so.
I think if you're talking about devices, check out our device repository. I mean, a lot of times, a lot of companies also spend that, which device are we going to get, and this and that. But I mean, just have a look at our device repositories. There's a whole range of different sensors that are available there. You can quickly add them. You can quickly buy them from respective distributors, and you can really validate your POC based on your business plan, based on your use case. So get started. We have all the tools, and if there's anything else that you have any questions or you have any doubts about, feel free to reach out, and we're happy to help.
Cool. Yeah, like you mentioned, the device repository, that is definitely something that we should highlight. I made a video earlier about how to choose a device for your LoRaWAN solution by using the device repository. And so there, it's pretty easy to go and sort by sensor, and then to look at all of the devices that are available in the marketplace, which can do the task that you need to solve your problem. And I shared a little spreadsheet that I made, which helps me to make a decision about which one I would choose. Let's see, we also have here, I want to hammer on how easy it can be to create your LoRaWAN solution if you use the steps that we've put in place in order to basically make baby steps. So we have this thing called cloud discovery, where you can get started with a enterprise grade LoRaWAN network server with a ThingStack tenant, and then you can easily get a device, onboard it and be ready in just a few steps, maybe even in a day, to having your first POC of your LoRaWAN solution. So these steps that you can make by piggybacking on these really highly available and highly usable systems that are in the LoRaWAN ecosystem can really help you to drive your business positive case as well. Thank you, Rish. I'll let you go, and we will get on to the last presentation of the day, which is building an end-to-end LoRaWAN application. So this is, again, one of our most popular YouTube videos, where Kevin and Neira, they go through the entire process of building a LoRaWAN application. So that means onboarding a gateway, onboarding a device. In this case, Kevin does 2 devices, and then he creates an application. He writes an application from scratch, but you could also use an existing no-code platform to process uplinks which come from sensors. And then in his case, he also does some processing of this information that comes from a sensor and uses that to send a downlink through the thing stack to another device and changes the color of a light. So I'll play that video now, and that is building an end-to-end solution with Kevin Schiffer. See if this loads here, and then we'll get right to it. Here we go. So this is Kevin, and afterwards, if you have any questions, this is a long and very in-depth workshop about how to build a LoRaWAN system.
Hello, everybody. I hope you had a good time so far in the conference. And now it's time for our workshop again, where I will be guiding you through setting up an entire end-to-end workflow or project using the Things stack. And I will cover a couple of things such as onboarding a gateway, specifically the Things indoor gateway, then also onboarding an end device, actually 2 end devices. So we will do something where we will be receiving an uplink in a server application that I wrote, and also we will send a downlink from our application to the Things stack so that it can be forwarded to an end device. So I hope you're excited. Let's get starting. So the first thing that I will do is I will set up the Things indoor gateway. The process is actually quite easy with the Things indoor gateway. We can use the claim gateway functionality. So I go over here to my gateways and then click on claim gateway. Then you can see that the form is quite a lot easier than the normal gateway onboarding form, because all we have to do here is entering the gateway UI, which I will just get real quick here. I have noted for myself already. And then you need a claim authentication code. So the gateway will be claimed, and we need to authenticate this request. And the Things indoor gateway uses the password that is written on the back of the device as the Wi-Fi password. So let's go ahead and do that. And then we can just give a name, an ID to our gateway. I'll just call it TTake Workshop, and then my name. And we can select a frequency plan. As always, go for the recommended one. We're here in Europe, so we use the European 863.870 frequency plan. And that's basically, we can just click now on Claim Gateway, and you will see that you will be forwarded to the overview page of the gateway that we just created. So all that is left to do now is actually plugging it in. So I'll just use the USB-C connector, and now we have to wait a little bit. Gateway starts blinking, so it will now search for a Wi-Fi network, and then after this it will try to connect to the Things stack. Yeah, as you can see, the onboarding process for our Things indoor gateway is actually really easy. It is just 3 fields that you have to fill out, and then the process is done and you can connect it to the network. As you can see, we have a connect gateway event here. If we go to our live data panel, so the gateway has connected and already sent us some status data. So that means that we're good to go with this gateway. So it's now ready to receive uplinks and also to send downlinks. All right, speaking of uplinks and downlinks, let's make sure we onboard our first end device, the Things Industries generic node, which is a really cool device that has many different sensors, such as a motion sensor, free fall, humidity, temperature, orientation, and it also has a button. So it is a really cool device that allows you to verify your use cases in the early stages, basically with one device that does it all. And it has a lot more features, so be sure to check that out as well. Let's go ahead and onboard this one. So to do that, first of all, we need to create an application. So since this end device, this generic node is measuring, among other things, temperature and humidity, I was thinking of an app that would basically keep track of the climate in my room. So let's call the app Climate Tracker, and then give a nice little name, Room Climate Tracker. Create the application, there it is, and now we can actually onboard the device. So we go on Add End Device. As you might know already, the ThinkStack offers you to connect with the LoRaWAN device repository, which is basically
if you are watching on another platform like YouTube or LinkedIn, you're watching the Things Conference Spring Global, and on this stage, I am showing some clips from what's happening on the main stage. So we're actually hosting this conference in Hopin, and in Hopin, you get to see all of the content live. You see it first. You could interact with the speakers. And on this stage here, I invite all the speakers after they give their presentations to come and answer questions live. So, so if you're interested in LoRaWAN and you're stumbling across this somewhere else, then please look in the description below for information about how to join into the LoRaWAN ecosystem. And you can even join this event. There should be an event, or it should be a link there where you can join, and you can participate in the conference in Hopin. So if you have any burning questions, feel free to ask. Otherwise, we coming up, we have the Things Conference. I always like to mention that because it's a lot of fun, and that's the world's biggest event on LoRaWAN. So that's in September. We have a really nice information page on thethingsnetwork.org/learn, where you can learn lots about LoRaWAN. Obviously, we have our YouTube channel where we have lots of information and lots of ways to connect with us. So even if you can't join this event right now, you can always follow us on YouTube, and we'll post all of this content on YouTube in the coming weeks. So you can follow along with the workshops and find us lots of ways. And I will let Kevin get back to talking about how he is right now creating an integration to allow him to receive uplinks from one LoRaWAN device and then use that to generate a downlink to another device, which he controls the color of a light on. So a big round-to-round, end-to-end application that he's building. And we'll put that on YouTube with all of his code so that you can follow along later and do it yourself. And then after this, in 10 minutes, we have a Q&A with Kevin and Neira, where they answer any questions that you have about building this end-to-end application. But if you want to get your questions answered, you have to join in Hopin. So if you're on another platform, look in the description, and we'll see you here.
This is encoded. So to decode the data here, I also have a payload formatter, which is actually not yet part of the device repository. Otherwise, you would not need to do that. But I have one anyway, so we can also edit manually. So we go to the payload formatters, and here you can see you have many different ways of choosing a payload formatter. You can use the application payload formatter, you can use a custom formatter, and then you have gRPC, cayenne, LPP. Keep in mind that you have two layers of payload formatters. The one is on the application layer. So a payload formatter that you set on the application layer will automatically be forwarded to all end devices. So all end devices will use this payload formatter by default, unless you set a different setting like we would do right here. But since we will also later onboard a different end device, which will use a different structure, a payload and uplink structure. In this case, we just want to use an individual end device layer payload formatter, which is what we will do now. So the payload formatter that I will set right here will only be in effect for this particular generic node that we just onboarded. So let's go ahead and delete this, and then copy out my payload formatter that I have here. And actually, one thing we can do as well, which I always like to do, is how about we just copy out the MAC payload that we just had here from our previous uplink message, go to the payload formatters. Again, choose the custom JavaScript formatter and already put the payload that we just received here into the test byte payload. Then again, go ahead, copy out our payload formatter. And then now we can do, as we are already working with the payload formatter, as we are editing it, we can see whether the payload formatter is actually working out. So we'll go ahead and click test decoder. And as you can see, we have a decoded test payload. So there is battery voltage information, button press, humidity and temperature. And so it appears like the payload formatter is actually doing what we want. So then we can go ahead and save the changes. And now let's go back to our live data. And since we now updated the payload formatter, we can do the whole thing again. We can press the button again, which I will do now. And now you can see in the data view, you will have another forward uplink data message event. And it already contains the decoded payload in the preview here. So you can see what this translated uplink message is actually saying. So we have, again, battery voltage 2.9. We have a humidity of 37.5 currently in this recording studio and a temperature of 23.2 degrees Celsius. So nice and cozy. So now we have an end device running on the Things stack. And of course, you don't want to have it just on a Things stack. You want to do something with the data. You want to forward the data to an application that is then doing something with the data that the end devices give you. So let's do that. And of course, if we want to do that, we need an integration. So there's many ways to integrate your application with the Things stack. We have an MQTT client. We have, of course, webhooks. But then there's also some platform solutions, AWS IoT, Azure IoT Hub, and the LoRa Cloud. But for the sake of simplicity, and because it's really that simple, I like to use just webhooks because it's super simple. As you will see now, we click on Add a Webhook. And maybe just as an explanation, what does a webhook do? It's basically nothing more than a request that is being dispatched to your server that you configure that will carry the sensor data to your application so that you can use the data based on an endpoint that you set up on your application. So that is also what we will do here. We go to the custom webhook because I have a custom application, so it's not part of any platform solution. So if you have something like that, you can always use the custom webhook. So let's go ahead and again give a name. So it will be the climate tracker webhook. Format usually JSON, and then the base URL. So mine is actually this address. So let's go ahead. The endpoint is /webhooks. And the only other thing you need to do is set and enable the uplink message, because that's what we want. Whenever an uplink message is received by the network in our application, we want this data to be forwarded to our webhook endpoint on our application. As you can see, you can set a lot of other things here as well. So if you're interested in whether a device has joined and so on, you can also choose specific events. But in our case, we just want the uplink message So we go ahead and add this webhook. Okay, so that is basically already it. The only thing now is my application is not actually yet running, so let's make sure that this happens now. And maybe just a few words about the application that I have. It's a really simple Node.js application. Everything it does is it exposes a server, an HTTP server, which will take the data that has been received through the webhook, and then it will display it the latest data that we received, and it will also put the data on a chart live. So whenever there's an update, the chart will be also updated live. Yeah, we have an endpoint that is waiting for requests coming in at the /webhooks endpoint. It will just take whatever it had received, and then it will push it to a variable in the memory, so that we can take whatever is in the memory and display it on our website. So let's go ahead and start this one. So I have to go here. No, actually one thing we need to do first, of course, we need to set up the application. So we'll have to go to the config file that I created. So we'll have to do two things for now. We have to enter the name of the app. So let's go back to the Things Stack console here. Go here, and here you can see this is our ID. So just copy that one out and then go back here and paste it. Oops. Paste it here. Go down, API key. Which
we are coming close to the end of our last presentation here, which is this workshop by Kevin about building an end-to-end LoRaWAN application. It's a really cool example, something that we saw that people really liked on our YouTube channel, where we show basically every process of creating a LoRaWAN solution. So Kevin is here. He is onboarding LoRaWAN devices. He is connecting a gateway, and then he is writing his own integration and showing how to get sensor data from a LoRaWAN device into the Things Stack and then into his third-party application, which he wrote himself. And then he's also processing that information and then scheduling a message to be sent to another LoRaWAN device based on the uplink. So it's really this full round-trip example that he's making here. And we'll share this example on YouTube afterwards, and Kevin will share all of his code so that it's easy for you to follow along and you can recreate this because it's a really cool example. Anything else that I need to share here? Let's check. We do have Q&A coming up where Kevin and Neera will be here soon. So if you're watching in Hopin, then please drop the questions in the chat. If you're watching on any other platform, the conference is actually being held in Hopin. So if you look in the link in the description below, there should be information. If you want to join, it's almost the end of the conference, but you can always jump in now and ask your questions. And otherwise, there's lots of information about how to join future events. We have some more webinars coming up. We have the Things conference in September. So we really, really hope to see you and hope you become part of our big LoRaWAN family. I will let Kevin's presentation finish, and then we have Q&A with Kevin and Neera here in about 5 minutes.
Which is a very nice LoRaWAN device. It is the QnA Busy Light. It's a light that you can control using LoRaWAN. So it uses the Class C capabilities. And so that means that Class C devices have a continuous reception window open. You don't have to wait for an uplink and then wait for the two reception windows if you have a Class A device, for example. So here the device is constantly listening for downlinks, and so you can send a downlink whenever you want. So let's take this device and onboard it as well, because what I would like to show you is how you can use webhooks not only to receive data on your server, but also to use your server to push data to the Things Stack, which is then used to schedule a downlink. First things first, we need to onboard our device. Same thing, we go to add an end device, and here's the thing. This device is currently not part of the LoRaWAN device repository. But that is also a good opportunity for me to show you how the manual onboarding works, which can also happen if you have a very new device or a device that is, for whatever reason, not part of the device repository. Then you will have to check the data sheets and then enter the information, the onboarding information, LoRaWAN information, versions, etc. You will have to add those yourself. And the console also allows you, of course, to do that. So let me show you how this works. So you go here to the manually tab, and then you will see you have a somewhat more complicated form. But don't worry, I'll walk you through it. It's actually not that hard either. So what you need to make sure is that you need to understand what is the device that we're having. So usually your manufacturer or your retailer will give you a data sheet, and the data sheet you can use it to understand what kind of a device is it, so you can onboard it manually on the Things stack. I have this PDF here, which is the technical documentation of this device. And in there we can see LoRaWAN version and LoRaF ports, so we can go right ahead and go there. And then it's just one little sentence here saying Mac version 103, and the frame port you have to use for downlinks is the frame port 15. So that is actually all we need to know to do the onboarding here. With one exception, you also need to know, of course, that this is a Class C device, and we also need to tell the Things stack that fact. But let's go and set the recommended frequency plan here for EU again. LoRaWAN version, we just heard 103. Regional parameters, luckily there's only one, so we don't have to know which specific revision it is. So that is also nice. It makes it a lot easier. If it would not be the case, your manufacturer or data sheet should also contain information about what regional parameters versions you need to set. Then we have just a normal OTA device, and as I said before, it is Class C, C for continuous. So let's set that. And then all that is left to do is, again, the registration data. So I go back to my nifty little sheet here.
So Kevin is just about wrapping up his workshop covering his end-to-end LoRaWAN application. And then up next, we have a Q&A with Kevin and Neira. So if you have any questions about their integration, their workshop here, please drop them in the chat in Hopin. If you're watching on another platform, this is the Things Conference Spring Global that you're watching right now, and we're doing this in Hopin. I'm on the Q&A stage, and so here I'm showing a little bit of what's going on the main stage in Hopin, and then also inviting all of the presenters to come on and do Q&A live. So in just a minute here, I'm going to turn off this main stage, and I'm going to bring Kevin and Neira on to answer some questions about building integrations. And yeah, so Neira, I think I see you in the backstage there. Give me a thumbs up if you can hear me, and I'll bring you on to answer some questions. Okay, let's see. So like I said, you're watching the Things Conference Spring Global. And we are here on the Q&A stage. If you're on another platform and you want your questions answered, please join us in Hopin. Look in the description in the link below on YouTube or LinkedIn or whatever platform you're on. Later, all of this content will also be posted on YouTube. But for the live part, if you want to sit front row, if you want to interact with the speakers, it's all happening in Hopin. So Neira, I'm going to bring you on now to do some Q&A. There's Neira. Neira, can you hear us? Hello, Neira. Oh, I don't know if she can hear us. One sec. So let's see. Oh, so we're waiting for Kevin and Neira to be available here to answer questions. If you have any questions and you're in Hopin, please drop them in the chat. Okay, Neira, will you give me a thumbs up if you can hear me? Still not sure. Oh, okay. One sec. Let me make sure everybody's in here. Okay. And let's see what else. Okay, Naira, I'm going to bring you on this time for real. Hope you're ready. Naira, are you there? Naira, are you there? Hello? Hello? Okay. And hello? Naira! I guess Naira is having some technical difficulties, so I don't know if she can hear us, but I can see you, Naira.
Yeah, I'm ready.
Okay, you can hear and see me?
Yeah, I'm here.
Okay, great. So yeah, we have a few questions. Let's see.
Hey.
Hey, welcome. Naira, you can hear me, right? I guess not. No?
Yeah, I'm ready.
Okay. Well, Naira, it looks like there's some kind of technical problem.
Here. Hey.
Hello? Not sure what's happening. Kevin's here. Here we go. All right, Kevin, you can hear me, right?
Yes, I can. I hope you can hear me as well.
I can hear and see you loud and clear. So I'll ask you Naira's questions. Do you have any advice for getting started building your own end-to-end application? I know you did a really nice example there, but how did you get the inspiration? What made you want to do that?
You mean how to get started easily? Yeah, so I think what I always recommend is a video from Johan that we had, I think, in the conference a year ago or so, where Johan is really going through the whole essential LoRaWAN stuff. So I think it always helps to understand what is really going on under the hood and how the technology works, because that will really also set you up to build your applications in a way that is actually as intended by the specification. And it might seem a little boring to maybe go and understand like all this technical stuff that is actually behind the thing stack and LoRaWAN, and what is actually enabling all the things that we're doing. But it's actually not boring. It's really interesting how everything is actually fitting together and how it is working out. And so this is something I can definitely recommend. I just don't have the link handy right now, but I can definitely deliver that.
The link for what?
The link for Johan's presentation on everything you need to know about LoRaWAN and things taking 1 hour.
You just go to the thingsnetwork.org/learn and it's
exactly it is there. Yeah, it's right on our homepage because it's so good.
Yeah,
so actually,
yeah, that is really.
I have a link here.
I think it's our most popular video on YouTube. So that's a good point. Learn as much as you can about LoRaWAN. That's also a good segue for me into talking about the thingsnetwork.org/learn, where we have lots of educational information, and also about our certifications program. So we have you can take a test, and once you've learned everything there is to know about LoRaWAN, we have 4 different categories. So fundamentals, advanced, and then some other LoRaWAN topics, and you can take a test and you can demonstrate that you know enough about LoRaWAN to pass a test, and to probably then to start actually working in the LoRaWAN field or to build LoRaWAN integrations, and you can show that off as a badge. And we also have a little sweepstakes going where for all of the people who score the best in our certification program, we'll invite you to the Things conference in September in Amsterdam. So definitely go and prove your LoRaWAN knowledge on the thingsnetwork.org/learn. It's good for you, and we'll really appreciate having you at the Things conference if you do really well.
Exactly.
Otherwise,
that's a nice incentive.
Yeah. The Things conference is going to be really fun. But this is the 5th year anniversary, and it's been 2 years since it was in person. So there's been no big global LoRaWAN event since 2019.
It will come back though, so we're all excited for that, which is really nice.
Exactly.
Yeah.
Okay, it looks like I have a few questions here. How can you add devices to the device repository? I know you showed how easy it is to use devices which are in there. So I guess if people are using a device which is not in the device repository,
yes. So I'm just going to check if I find the link here real quick. So the device repository is basically an open source repository. So everyone can help us to make this repository more complete. And it is literally a GitHub repository. So you can open pull requests or open up issues, and you can help us complete that. Either if you're a device manufacturer yourself, so you want to make sure your own like the device that you're building yourself is being presented on the device repository, or if you're just a user of a device and you think it would be nice to have it in the device repository so that you can more easily onboard your device, then that is also perfectly valid. So I have the link here. I will also put it in the chat, and that is how you can add some devices there. And it also has a pretty complete documentation on how to do this. So I don't want to bore you now with the details, but it is really easy.
Yeah, so it's open source. Anybody can add to it, and so if you have information about a LoRaWAN device, go and create a pull request.
Yeah, it's maybe just one more thing I want to add about this is so it's really also it has been a great tool for us as well, because I don't know how aware people are of how complicated the specifications for LoRaWAN devices can be, and how many different versions and regional parameters there are, and they all come with different settings, different MAC settings, different device settings, and settings regarding LoRaWAN in general. And so if without the LoRaWAN device repository, users have to really know what is the device that they're onboarding, and with the device repository, all this work is basically offloaded from you, and everything you have to know is basically the registration details, which is typically the app UI, join UI, the app UI, def UI, and the app key, and that's just 3 values, and you're good to go. So that's really nice.
Cool. Okay, so in the chat here, you have a compliment. That was a very good presentation and could be followed very well. So thumbs up. Somebody asked if there are any ready to deploy LoRaWAN gateways for sale. You used one. I think there are plenty, but yeah.
Definitely, there are many ready to use, and of course we as the Things Industries have to highlight the Things Indoor Gateway, of course, and the Things Kickstarter gateway. But there are many off-the-shelf gateways that you can use that are basically just ready to go and require no big configuration or anything. As you can see in my presentation, that using the Things Indoor Gateway. We have the claim functionality, which also makes it even easier to onboard that device. So setting up the devices is really not any hurdle anymore. It's super simple.
Yeah, we also have lots of information in our documentation about all of the gateways that are easy to use with the ThinkStack. It looks like Naira is working. I can see her giving a thumbs up in the backstage. So maybe Naira has some quick wants to answer some quick Q&A.
Hey guys.
All right, Naira, you can hear us now?
Finally
right,
I can
great
hear
to
you.
see you on here. So let's see, what do I have?
By the way, I have to say that Kevin, your session was pretty amazing.
Thank you. I'm glad to hear. Thank you very much, Naira.
Yeah.
Okay. Let's see. So Naira is our migration expert. Naira, do you have any advice for say, migrate for getting your end-to-end applications on board in the ThinkStack in V3?
Yeah, well, the process of migrating an end-to-end solution from V2 to V3 is something that was like a hot topic in the past few months. And I have to say that people generally kind of found it hard to do it at first, but then after everyone was kind of caught up with it because V2 was shutting down and yeah, the whole situation, I think when people finally started to act on it, it went even better than we expected. And we also see a lot of positive comments about using new features that come with V3. Also, we as a team also worked hard on documenting the migration process very thoroughly and making these video guides and talking about it on our past conferences. So I think that generally it made the whole process a lot easier. We still have, I think, some private V2 deployments, and again, we want to encourage everyone that is still sticking up with V2 to finally make that step towards using V3 because it's better in so many ways.
I think we probably have a lot of people on here who don't even know of the existence of V2. I think it's been a while now, so, which is great.
It's good, yeah.
And the thing stack, yeah. So Neira is referring to the migration of especially the Things network over to the modern Things stack, the LoRaWAN network server that we use today. And usually we don't really, yeah. So that migration is basically complete. We don't support the old version of the LoRaWAN network server anymore, but that ran for a long time on the Things network. So for any legacy users in the audience here,
also
hopefully you've gotten used to
the old
we're,
days.
we're now working on the content to also help users to make the step from the public community network, the Things Stack Community Edition, for example, to the Things Stack Cloud. So I guess for people that are looking into like transitioning from that community network to a bit more professional environment, that will be an interesting content to follow.
Yeah, so there's lots of good migration documentation written by Neira about how to do that. So how to move from the free the community network, which doesn't really have any guarantees about uptime, to the Things Stack, say Cloud, for example, which gives you all of the same functionality. It's also managed by the Things Industries, but then comes with an SLA and uptime guarantee and some other features which are only available for enterprise customers, basically. But we are about 10 minutes late here.
Because of me.
So I'm going to, unfortunately, I have to cut off this Q&A in order to bring on our final guests, Vinke and Johan, who are waiting patiently in the backstage. So I'm going to let you go, Kevin and Neira, and anybody who has any questions about integrations, about migrations, about building LoRaWAN solutions, please reach out to us. Our email address is up on thethingsnetwork.org/learn, and yeah, there's lots of other places to reach us. So follow us on YouTube. See you at the conference. Thanks, Neira. Thanks, Kevin. And
thank you.
And I'll see everybody again soon. Bye, guys.
Bye, bye.
Thank you, Ben. Thanks, everybody. Bye, bye.
All right. So the moment everybody has been waiting for. You finally get to ask all of your burning questions to the founders. This is a Q&A with the founders, and I'm going to bring on Johan and Vinke now to answer all of the questions that everybody has.
Hey, Ben.
Okay. Hey, everybody. How has the conference been for you guys so far?
It's really amazing. I'm actually learning a lot of stuff myself, so it's good. It's always hard to see yourself back, and I'm really glad to see that our team has become better speakers than us ourselves, so it's good.
Yeah, the public speaking part is maybe the most difficult part about this online events. But soon we'll all be back in person in Amsterdam.
For sure, looking forward.
Yeah. What would you say is the most exciting announcement today? I think, Vinke, I think you're on mute. I can't hear you. Johan, what would you say is the most exciting announcement of the day?
I think overall it's really good to see everything coming together and everything working really seamlessly and integrated. Yeah, we hear you, Winke. Thanks. I think product-wise, what we have been working on a lot in the last few months and has been the most demanded feature, I think, from users, customers, is definitely the Network Operations Center. So having this really great insight in what is going on in the network, how the gateways are performing, how all your devices are doing, all activity over a longer period of time. Because currently we have the console for live insight, which works really well if you have the console open. But if something happened yesterday or 2 days ago, there is not an easy way to dive into that. So we have customers doing all that monitoring themselves, and so I think it's really nice that exciting about this feature that's going to be usable by all cloud customers.
Cool. I didn't even realize that the historical aspect is such an important part there too. Yeah. Cool. Vinke, now that you have sound, what was your most favorite exciting announcement today?
Yeah, no, so like Johan said, they learned a lot. I think then I of course learned even more. It's really great to see everybody showing off their work, and that the entire team can present what they're doing. I really liked the CLI video. It's one of these things that like people move as a beginner, and then in the end they end up as a power user, and yeah, that's actually the perfect UI actually, if you're going into these thousands of sensors. And this year we'll be hitting 1 million registered devices, and it's a lot of customers have large amount of devices, and then actually the CLI and scripting through it is not only the most fast way, but it's also the most responsible and secure way if you're ask any DevOps, right? So yeah, I really love that session.
For sure. Yeah, I know you pushed a lot for this. Don't be afraid of the CLI as a content concept. And I think that a lot of people are just holding on to doing things in the console because it seems like too big of a step. But Hilke made a really good point that it is actually a really nice intermediate step between, for example, coding your own integration using the API. And if you just you follow along using an example like Hilke made, it's probably pretty easy to get started doing stuff in the CLI, and it's really, really powerful and really stable. So I hope that that a lot of people follow along with that and learn some things there. What else? We had a lot of amazing announcements today. So the new join server, that was exciting. The NOC, like you said. I'm really excited about device claiming. Let me see if we have any questions in the chat about other things that people are curious about. Let's see. Ooh, will the community network get a NOC Lite? That's a good question.
No.
Easy answer.
Yeah, because
it's a lot of data.
Well, we'll need to think about what we do. We may have sort of a public page where we provide some insight. That's definitely something we can think about. But the way we currently design a NOC is that you need administrative access to the network, to the tenant. And even though everyone can have access to the Things network, we don't provide administrative access at the moment to the community network. So that's the reason. But we'll think of something. Let's.
Oh
no!
Lost your sound, Johan. Technical.
Oh shit! Yeah, I'm. Sorry. I'm the same thing with. Do you hear me now?
Yes.
Yeah, Vink is also always playing with this thing, and
yeah. Do you all have this?
Mine just with the dying noise, right?
Yeah, you should leave the thing alone. Yeah.
It looks like we have some questions about picking a device. I made a little video about using the device repository to choose a LoRaWAN device for your solution, but I guess that's something where we can, in the future, make it a little bit easier, because I know that a lot of people are watching the videos, for example, comparing all of these different gateways or different devices for a particular solution, because I think that is a pain point that people still have if they want to get started. Okay, what device do I pick? So that's something that we can work on in the future for sure. What else is here? LoRaWAN in Africa. Any updates
So
there?
is that a question or?
Somebody wrote LoRaWAN in Africa, question mark.
Why not? Question mark.
Yeah, why not? Well, I think there is this. I don't think the regional parameters cover African countries at the moment. I know that many countries actually follow the ETSI regulations, including South Africa. Those countries would be able to use the EU 868 band without any legal issues. For the others, I am not sure what the status is. So unfortunately, LoRaWAN is not officially defined for every single country in the world, and that's really because of all the differences between the frequencies and the transmission powers and things like that that are not harmonized sub-gigahertz globally.
Yeah. But I've seen some amazing, let's say, projects. I think they're well known are the tracking of endangered species, but also South Africa has quite some use cases. 2 weeks ago, I spoke to a Swiss company who's doing water management on a resort in South Africa. Very interesting. So yeah.
Somebody asked about 2.4 gigahertz in TT and TTI. What is the status of that?
Yeah, so we have support for that. Unfortunately, there is no official LoRa Alliance specification for it, but we do support LoRa 2.4 gigahertz.
Okay.
It's LoRaWAN compatible. And there is not that much hardware available, but there are some gateway vendors that are shipping 2.4 gigahertz gateways or dual band gateways that can do both 2.4 gigahertz and sub-gigahertz. So technically we have availability. Unfortunately, LoRa Alliance decided not to formally specify it, but we have technical support.
And the new Johan, the new LR1120, right? That has also some has a 2.4 official. Okay.
Yeah.
Are we doing anything to help with Sigfox migration?
So then the question: what do you want to migrate?
Yeah, I think.
So. I think this. Technically, you can't migrate because Sigfox and LoRaWAN are not compatible. So basically, what you're doing is, if you want to move to LoRaWAN, then you just start over.
Yeah. Okay.
That's basically what you do, and yeah.
That's a simple answer. Somebody asked about battery-powered gateways, but it looks like Jack answered that question in the chat. Gateways use too much energy. Maybe there are some solar-powered installations, though. Do you guys know? I think I've seen a solar.
I think it was a company from the UK was quite a big installation.
Yeah.
I'm curious. Would be curious about the use case of a battery-operated gateway.
I'm very curious as well, yeah, because you have to have constant network connectivity. So, yeah, let's see. Maybe there are some helium questions in the chat, but I don't know. Yeah, it doesn't look like there are any other pressing questions here for you guys. Do you have any last comments that you'd like to make before we wrap up?
Yeah, come to our conference in September, because I think it's become like a thing. I think it's a thing on its own, and it's not because of what we do, but it's because of the audience that comes there and the way that people present their ideas and plans and technology. And this is still we're going to announce more of this later, but we're going to build the world's largest digital twin using this massive amount of LoRaWAN devices we have in the ecosystem. So there again, what we're trying to do is to present IoT with what you can do now, and not the castles in the sky or the. So come join there and see how far and mature LoRaWAN is, and specifically for people that think and learned about LoRaWAN 3 to 4 years ago, it's really like it really would benefit you to revisit, because it becomes so much more mature in the years.
Yeah, and we have some really big surprises planned for the conference. So
yeah, that's
we'll have a good
it's going
time.
to be a lot of fun.
Yeah, just it's been a long time since we all saw each other. So
yeah, for sure.
Yeah. Well, I don't think that I have anything else that I need to hold you guys for. Johan, last word.
No, I totally agree with Vinke. I'm very much looking forward to seeing everyone again in person this September.
Great. So like Johan and Vinke said, we have the Things Conference September 22nd. I think if you're watching on other platforms, there's a link in the description where you can find out more about the conference. Otherwise, thethingsconference.com. And yeah, thanks everybody for participating in the Things Conference Spring Global. We have some more webinars coming up. I think the next one is May 19th. We have agriculture-focused vertical webinar, and yeah, just lots of content all year leading up to the conference in September. I hope I covered everything.
And thank you, Ben. You're doing this really, really well, right? It's I really like that's pretty awesome.
Football commentary.
No,
absolutely.
Super cool.
Yeah,
I think people really love these videos around comparing the gateways. I've got so much good feedback. So
yeah, it's cool to get to hear what the community is asking and then try to answer those questions. And I'm also curious about people on LinkedIn, people on YouTube, all the people who we reached who are not usually in our Hopin platform. So hopefully we made some new friends today too. All right, everybody.
Hey, bye.
Bye.
The end of the Things Conference Spring Global. Bye.